guess now we are live. Hello, everyone. Today, our focus will be on, you guessed it right, on gradient topic, and we're gonna solve a lot of problem. Hopefully, all right. Um, Yesterday we have completed these problems. All right, now today, starting from here, we're gonna first complete these problems and after that review all the questions we have here. Hopefully all of them, alright? And we have our amazing timer here, alright? It's gonna show us how many minutes we have spent so that we can keep track of time. This is my local time. And we have some surprises today. Stay tuned. And this is a hint section coming from our viewers. All right, that is gonna be so fun, guys. Let me check my stream once more before starting and suffering the lead code. um, I guess it is. It is good. Yeah, it is wonderful. It is wonderful. All right, so leave it there, stop it, and resume it. All right, so we officially started our 18 hours long session. Wish me luck, guys. Like, I know it's gonna be so fun, and that's the important part. All right. Forget about understanding lead code or anything, but no. Like, we are here to, understand, of course, capture the fundamental idea. So, our first question is this: removing stars from a string. All right, so you are going given a string s which contains, yeah, so let me look at the input. We have a string here, guys, and it seems that we have some stars. Actually, to be honest, guys, I seen in the one liner that I can use stack. All right, so we already moved that part, like, I mean, determining which data structure we need to use. Like, this is an important skill as well. This is what I mean. And let me also resume the official Pomodoro. Yeah, so um yeah, so the output is licoe y explanation. Performing the row, we need to remove something. Performing the removals from left to right, the closest character, the closest, guys. Actually, we have a term for that, right? Like, what was it called? Like, in stack, like, we have a top, right? And then, all right, I can ask, like, there was a special term for incoming character, um, that welcomes incoming character. Front facing or something else, so the closest character to the first star is T. Yes, it is the closest. um S. So we remove T and we basically sacrifice a star to remove the closest one. But since we have like a two neighboring stars, like, we are looking to the left side, all right? Since the left side of this star, we have another star, so there is no problem with that. But for any star that has other than star on its left, we remove it and we also sacrifice ourselves. I mean, sacrifice that uh, star, basically, right? The closest character to the second star is E. After we remove, then our mechanism, our structure should dynamically recognize the change immediately after. we make a change, and again we have a e. All right, we sacrifice that too. So and also we go from left to right basically. All right, and we need to sacrifice these two. All right, all right. So basically, guys, like imagine you are a starship, right? All right, and you kill. I mean, you know kill some of the stars. Like there was a game like this, right? And so I don't know. Like it reminded me of that game. So how do we code it? Since I know, like sadly, like maybe I should change the one-liner because I've seen this tag. But all right. So now we need to think about we need to think output is what? Oh, we sacrifice and then this and then that and then or we remove all of them. So yeah. Um Given that we know we should use tag, now what should we do? We should be smart and find a way um, to use a stack here. How do we use stack in Java? All right. Actually, I already activated our teaching assistant. Now we start um, we start solving this question, and my first question is that give me an example of a stack implementation. As Lazy Skimmer said, implementation, my viewer, Lazy Skimmer said that once the implementation has its own details, right? So here, apparently we need to use a stack. Could you please, don't give us hint, but in general, how do we use stack in Java? I wanna see it. Like, why do we don't see um, the dictation bar appearing on the bottom of the current. um, Let me maybe reopen it, because if you see it, it will be more understandable, I think, for you to see that I'm dictating, not speaking. um all right, so maybe, guys, I can move where, maybe move here, right here. Wonderful. Right. um all right. So direct API reference, no hints, just how stacks work in Java. Yes. So maybe we can even make this a little bit bigger for our viewers from mobile. Let me zoom in. Yeah, it is, I think, better. Two ways, the legacy stack class, rarely used now. Oh, so we literally have a class called stack, I think, right? Generic class. Stack push, all right. So, but we don't use it, all right. The idiomic modern way is the queue. All right, so let me also copy this part here, guys. So like here we can type our answer. All right. What methods we have for this stack? Like a push pop. We have peak. Yesterday we have used this actually for queues. Um, and that queue was priority queue, but this is array queue. All right. So could you please show us some methods from priority queue, DQ, and array DQ, and also like from the perspective of object-oriented programming, show us the definition of those classes. But actually, all right. So show us a little bit of those classes, all right, and their methods, and also we need you to add a note in my website, all right, stream notes, and give me the link so that I can uh, share it on my Twitch, right? This is gonna be our first note about stack implementation detail in Java, and then its methods, and then the difference or similarities between these classes, basically, right? The queue, array queue, priority queue, because they all share same methods. Because yesterday we have solved a question using a priority queue, and there I've seen like a pop peak method and exception methods. Let's see, guys. I don't know why, but the dictation bar appears on my other screen, but it doesn't matter that much. All right, it is now even better. So how about our question? Our question. So now the logic part. We can focus on the logic part. So we literally, so we need to insert each character, right? How about we insert like add or push each character like in this way, and as we like when the incoming character is star, instead of pushing it right into our stack, how about we pop the top pop from top, all right? So let's remove let's get rid of this, all right, and we don't push it, and we go forward, and now we have another star, right? um, so for that we need to pop again and don't push it, basically, right? All right, and then I guess this is gonna be our solution, basically, right? Yeah, we've done this too, and then C, and then O, and then D, right? And then when the third star comes, we don't push it, but instead pop, um, and then add E, right? And let's see what we have in our stack from bottom to up. And also, like, there is a movement about, like, the thing is, guys, do we okay how are we gonna pop the remaining elements so that we're gonna get this, alright? Because if we pop here and put it first, like this one, like a E, O, like a E, right? O, C, E, L. So we are gonna have this one, but instead we should have like a do something about it, and it should go go this way, right? L, E, C, O, E. So I guess this is the answer. Now for us to implement, so the logic part is easy. And I think the gritty part about this question is that the fact that we just pop the element right away. Maybe this is good. I don't know. We can focus on what was it called, guys? Exchange argument. We can ask this. We can ask about this after solving. Right? Um. So the class interface hierarchy. So Q is an interface, guys, and it extends collection. FIFO contract. Oh, that's nice. That's nice. The array the Q, I think, implementation of these interfaces and a child of this. So we have all the methods coming from here, all the methods coming from here. So and so also we have a priority queue, which is heap action, right? We use it yesterday for min heap, right? Let's see. The key object at the point, not where priority queue sits. array, the queue is a the queue. Hmm. The the original one is this queue. We can check the hierarchy here. I mean, um, array the queue queue. All right, so array the queue. Here we have it, right? Array the queue, and then queue. So yeah, so this is the original one. This is the Godfather, right? Let me move. Anyway, let's leave it here. So array the queue, dq, and queue. So it has both the FIFO methods and the stack methods. Priority queue is a queue, but not a dq. It has offer poll pick, but no push pop, because a heap has no ends, only a min. Oh. So what you saw yesterday as poll and pick were queue methods. The heap just decides which element comes out. So to add a feature or ability, all right, or an attribute to your class, you can basically implement an interface, and basically you make your class, you know, enhanced, basically, all right. The methods and the acceptive versus quiet pairs, you notice this. Oh, acceptive. That's an interesting word. So operation insert, remove, and examine. Um, Q doubles this for both. Alright, alright. We can look at these details later. Um, yeah, save it with the current timestamp, alright, and deploy it, publish it. While it is publishing it, now we can focus on um, our implementation. So we basically need some sort of for loop, right, guys? Integer I starting from 0, all right, and like we should stack push, right? The method was this: push what? Push the s character at I. So I is smaller than s length, right? So we basically push, but but if the incoming character is if the incoming character is a star, we pop. But for us to be able to pop, we need um you know an element. Like we need to have an item in our stack. So if we don't, then we should add it, we should push it. So if um if stack size, do we have? Yes, if stack size, if it is empty, right? If it is empty, then push it. Stack push, pushing what? It is empty. And also if it is star, so maybe we should, like, we can type it, code it better, like a more readable way, but let's, for the sake of time, let's do this like this one. If the current processed character is a star, like, are we doing this like this? If the character is star and if our stack is empty, push the character, all right? um if it is not empty, it is empty, we need, So basically, guys, I don't want to use nested ifs, but anyway, so if it is star, if it is not, we just push the character into our stack. So if the star and if our stack is empty, we do this. If we have elements in our stack, now we pop, basically, right? We pop. We get rid of the last character we have. I mean, at the top, and then no, we don't push the incoming star, but we only pop. Um, but we need to have some elements inside our stack, so we have this if. All right. Actually, we can do this on lead code too, right? So we have this method. All right. So now we need to, I think, remove something, right? I mean, return something. Like we add a push pop, and we should return. All right. We now, like after this for loop, we should basically turn our stack into. We should turn our stack into a string, basically, right? Yes, like we because we return string. So how do we convert stack uh, into string? So let's look at this method and returns a character. So this might cause an issue for us too, because in our stack, oh, we already have a character. Um, how do we, like, I don't know. So let's see. We can make use of our amazing AI. So now I need you to create another entry, all right? And for okay, I realize that I don't know how I can convert a stack to a string, basically, right? And we push characters in our stack, so we should be careful about it. So now add a timestamp and create a note about this situation, and also show me some hints, show me some examples about converting, you know, stacks to string, or maybe integer, some others. Um, all right. Heads up: the demon's tail environment will bite again on your next notice session. Each save will report. Others run manual. Restart the control panel daemon to it picks. Oh, all right. And also create a memory about this heads up you mentioned. All right, we can do it later. So let's open. All right, it has created. So queue, the queue, array, the queue, priority queue. So we can actually, for object oriented, like a review or study, we can analyze these more in detail. All right. So basically, like I guess like this question is done, guys, but we need to find a way to turn our stack into string, and we push characters in our to our stack, so we need to be careful about it. All right, we need to be careful about it. um Reasoning invariant, stay ahead, stack pop on, running stack invariant, like I guess, um I guess we've done it, guys. I guess we've done it. I mean, but if I didn't know I could use stack, then maybe we may have spent a little bit of time, right? Because understanding or discovering or exploring or recognizing you should do is a is something, right? We have conversation builds block. String value of, yeah. We have these puzzle pieces. String builder plus append. But here's the question that matters most. Predict before you write. Your stack currently holds after processing with E on top. Yes, like this is the question we have asked, guys. So like E is on the top, last push. If you now pop repeatedly and append each character, the order does not will not be in order that we want. I get reverse order, so I need to reverse. So this is the answer. So like AI goes somewhere crazy, guys. Like it asks the question, and here it gives us the hint already. So I guess I get what it's saying, guys. So maybe we should use like since we have this, right? And maybe we can create a string builder, right? This is a magical class we have in Java. But I guess this is not the is this correct way of initializing? So I guess it is. So we can, guys, um maybe while we have, I mean while our stack is not empty, guys, all right, we can just append, like we can add it to our answer. What? Of course, the stack pop, right? So we can add this. So, and after that, we should some sort reverse, like we already have this amazing method reverse, wonderful. And now like we popped from our stack, get the elements reversed, amazing. Now we should convert a string builder to string, right? And I guess we can we have this amazing method. Like so, let's all right. So we are in string builder class, guys. Like we have this amazing class. This is override, and the place it comes. I mean, the class or interface it's coming from is like. Can we see it? All right, no. Um, all right. Let me add this too. So now I need you to create another um, another entry in our website about the toString method inside string builder. Like we have found something, right? So the thing is like, can you also add there about um, which class it's coming from actually, right? Like because we override, but which is the owner, like which interface or a class um, it contains, it owns these methods. Like I copied the code from string builder class, and I wonder the owner of this method, all right? And also one more thing, guys. And also one more thing is like we use like override annotation for both um like a like a extend like an inheritance, right? We can override the methods that we inherited from our parents, and also we can override the methods like a for like interface methods, right? So we use these annotation for both cases. um let's see how it generates. Also we have the timestamp. Yeah, so building a string from, yeah, so basically we have like a string value of method. It is a static method, and we have character to string. So we literally give the character as an argument, and we return. So I guess to string method is a special method that most of the classes implements or overrides basically, right? So if we do this, yeah, so like this is important information, guys. Like if we like in our heap, we create extra objects when we do this. Like I've done this before in a recursive method, all right? And that method was get taking a string as an argument. But I realized that I create new string objects each time I call. It was like an enlightenment moment for me to recognize the cost of using string as an argument, because it is like it takes some space basically, right? Because it is a complex class, like it is not a primary, right? Primitive, no, it is not a primitive. So we can look at the cost of it now. So who owns the string object versus car sequence? Yeah, so and override on interfaces. So we'll look at string build string, so and ask who really owns this method. Yes, we've done this. The root owner is object class. So in Java, every class extends object class. So every class inherits basically. The default returns. This is nice. Like guys, look at like I was gonna say like look at this beauty, but the ugly. This like you have seen, alright. So the copied body do not share the array. String builder is mutable. Or rather, we can read this later. Um, Make the problem. So, like, the way we have solved our problem, guys. Mm, yeah, I think we've done it, but let me copy the code, guys. Copy the code and open lead code and paste it over here. It seems nice. Let's run it and get our first compile time error. Oh my gosh, guys, this is the first time I got accepted in the first try, guys. Oh my gosh, guys, that is just wonderful. That is sick, guys. It's awesome. I guess this is the first problem, little problem that I got accepted at first try, but it was relatively easy question. But let's not demotivate us by saying like for the problems that we have solved they are easy, and for the problems that we can solve we are stupid. No. Don't do that, all right? Be grateful. We can continue, guys. We can restart the timer. um all right, I'm trying not to look at the one liner. um we can we can create a new group. Salt. Oh my, one machine there, guys. So lead code. Let's see. This is our new question. This is our current question, guys. And I'm not gonna paste to the uh, note. Alright, I don't wanna read it. Alright, so let's paste it. Alright, let's see the other example. And also maybe I can click on another question so that I won't have to worry about seeing one liner. So this is our question, guys, and now we can wrap up and make our AI to wrap up, because now our current question is this one, right? Let's copy here. Thank you for your cooperation, Sergeant. And now we will continue with this question. And can you please create a timestamp about the beginning of the question, all right? So that on YouTube we can see that now we started solving this question, all right? And do it for every question, and also update the this oh my update update stream.java class, all right, and prepare it for our new question basically. Press enter, and also guys, I need to update the topic. Topic is now minimum number of swaps. I guess we have solved some questions like similar to that in dynamic programming. Swaps to make the binary string alternating. Did we? No, no, no. Oh, that's nice. That's nice. That's... I guess, guys. I guess, guys. I remember this question, like a similar question asked during a real interview. Yeah, yeah, yeah. I kinda remember, guys. I kinda remember. Uh, like let's see, let's see. So we have set the topic, and let's go. And I guess I can increase the background some. Anyway, so guys, we have this. So given a binary string, return the minimum number of character swaps. Like this question is looking hard, guys. All right, because uh, like it has a minimum inside of it, and it asks minimum number of character swaps to make it alternate. So the string is called alternating if no two adjacent characters are equal. So we basically x, like we should have x y's, x y's, x y's, all right, like a different, right? For example, the string alternating while the string is not, all right. Any two. So we're gonna do some swap operation and maybe some indices, right? But which one are we gonna pick? All right. For example, take this as an example. Um, for like I mean, in this example, for example, you can okay choose this one and swap with this one, or maybe this one, right? You have lots of options. If you try to draw the decision tree, like you cannot, you won't be able to draw it because like it is not possible because like which like for which one do you plan to draw this into? Like there is like it is hard, all right? And when drawing this into is hard, we should think something else, all right? We should find another parameter. For example, in buy and sell stocks to question, we like there we had days to buy and sell, but at the end we figured a different parameter, all right? And instead of like a selecting or choosing as buying day or selling day, we focused on the consecutive days with increasing trend basically, and we sum them up basically, right? um so here in this question I sensed the similar thing, all right? So instead of deciding for each item, maybe we can do something else. And it says one. Which one it is, guys? I mean, if we move this one to where? By swap. Alright, by swap, we don't move this one and then move this one here. We basically swap. Like we have this term swap. So we basically pick one zero, and pick one. So we swap them. So we change position of uh, two characters, two items basically, with one call, right? Um, and by swapping, what do we get? I mean, what do we get? Like, let's say we picked, right? We picked like index one, right? Index one, 0, 1, 2, 3, 4, and 5. So if we pick 1 and 4 and swap them, but how did we magically pick this one? Like the thing I was gonna say is that like maybe we can focus on like finding that kind of like a new argument, like in this buy and sell stocks too. We had that idea, or we have this idea. Maybe here we can have something similar, but that what that might be, what might that be? So maybe we can focus on exchange argument here, guys. Exchange, like this is saver for us, exchange argument, because when you don't know what to do, like this breaks the need of case analysis. All right, so this is our saver, but how do we do that exactly? um Exchange argument, we may ask this about this AI to AI. I mean, we should obviously select two indices, but without selecting two indices, how do we know which how many swaps we need basically? All right, let's focus on this, guys. Like, forget about guys. Like, if you like, if your option is like selecting two indices, this is not the way. You can immediately forget about it and try something new. All right, welcome, C program lover. Welcome, how are you? Um, so instead of selecting two different, indices, like we should find something else. So we have, let's say, three number of ones and three number of zeros, but their positions is also uh, positions are also important, right? Because we had three ones and three zeros, like in this order, and that won't matter. So maybe we should count something else. What might that be? Um, Maybe count the differences. I mean, let's count the consecutive ones, right? I mean, for ones and zeros, right? Let's count that. Because for example, we have one occurring one, right? I mean, the neighbor one, and we have it again. So for ones we have two neighbor one. We don't need to count this. So we have two neighboring zeros. So, and what do we get from swapping? Actually, by swapping, we can, I mean, like it is dangerous, guys. I mean, so let's examine the situation, guys. For example, like what I mean is that let's have one here. All right, let's like this is one that we are gonna swap. All right, we don't like we may have some other like a zeros or one, and let's say we have zero here, and we may have some others, right? So what do we get? What do we get from, I mean, by swapping this? I mean, maybe these x's are already one, all right, and making or changing it to one is a not bad option, basically, right? That might be. Um. So what do you say, guys? So apparently, knowing or trying to find the two indices to swap is not an option for us. Even if we find some way, that's gonna like it is not gonna help us. All right, because the interview will most probably ask you about a better and faster option. All right. It does not matter to find those indices. What matters is find something new. Like we tried counting the, actually, like, what is the constraint here, right? Let's focus on our constraint. Our constraint is we need to make sure that they are alternate, or like, also another question now is that, guys, is it guaranteed to be a solution? Like, do we have something like that? Any two characters may be swapped even if they are not adjacent type. Of course, we know that. Return them. It might be impassable. All right, that makes the question even more fun. um. All right, guys. Let's think about it, guys. Come on, we can do it. Like if we focus on the exchange arc, we're gonna make it, guys. Be easy, be easy. Um. So we have ones and zeros. Like, we don't have the third option, right? And also, guys, let me uh can I wonderful. Pause, stop, start. All right. Um I can move it to here. So we can solve this. So we have only two different items, right? 0 and 1. So we don't have the third one, basically. Like, this is one of our constraints, basically. And we know that we shouldn't focus on finding those indices. It is wrong. And now we are like, let's focus on the choice. All right, let's try again drawing the decision tree for this one. But drawing decision tree does not help us, so forget about decision tree and focus on exchange argument. All right, forget about the case analysis. It is not helpful. Our goal is to focus on or find the exchange argument. But how do I structure it? I don't know. I know this is the way. I know, like, we were doing something like O, I guess representing optimal, and we had some G, right? I don't know, like something like that. And we prove, I mean, like, we prove that if our move is better. Oh, TV Josh, welcome, welcome in. This is this question. Actually, the current topic is minimum number of swaps to make the binary string alternating. Welcome, welcome in. Um, so we know that it is greedy. We know that we shouldn't try finding those indices to swap, but instead we need something else. And also we know that we should focus on the exchange argument structure, because this helps in every greedy problem. And we know that there is something called optimal. Alright. And we try to prove something. um, Maybe I can ask AI. So now, like, we started solving this question, and like, I tried drawing decision tree, but this doesn't help. It doesn't help. And also, like, we shouldn't focus on finding the indices for swapping. All right, this won't all help us at all. Even if we come up with a solution like using that, the time complexity of it will be, I guess, too bad, basically. And we should focus on something else. But the thing is, I cannot find it. So I don't want to do case analysis. All right, I hate it. um, and I know that exchange argument approach is gonna help us, right? This is something amazing. And for but like, even though we've seen its implementation or its logic in our previous greedy problems solutions, since for each greedy problem there may be some different exchange argument, basically. But like, there I know there is some generic idea behind, implementing this exchange argument, but I'm failing. So giving us like a real without giving us like a big hint, just guide us, all right? Overall, like what idea of exchange argument, and yeah. All right, now let's see how AI is gonna, what is gonna tell us, all right? Um, and maybe we can make online search about exchange argument or already. Exchange argument is a standard mathematical proof technique used to establish the optimality of a grid algorithm. It proves that the grid choice always results in a global optimal solution. Yes, so this is our goal. So G and O thing. All right. Define the solution. Let G be your greedy solution. Uh, yeah. But how do we define our solution basically? Like, um, I mean, and O be any arbitrary optimal. What solutions are not greedy? Well, what do you mean by that? I mean, what kind of question is that? What solutions are not greedy? Is everything greedy? So, if you have choices, all right, basically, multiple choices, but one of them has some, priority or dominance over others in every cases, you pick that one and you basically code it. So dynamic programming and the grid shares this logic basically. You may say, like, do we have multiple options for each problem? uh Sometimes we do, sometimes we don't. But for grid problems overall, um we need some options. For example, here we have like dozens of like pairs we can pick to swap basically, right? But which indices are we gonna use? So apparently one of them has some dominance over others. Did I understand your question correctly? And also you can use hint comment in our chat to send me some hint. um yeah, so which algorithm or kinds of algorithms are not greedy? Like, for example, actually, like in the previous question we have used stack, and there, as we push an element, we popped the other element, and that was greedy. And for example, sliding window, for example, we had two pointers technique in a, for example, sorted array. We compare the characters, and if it is smaller than the, actually, like, there is some rule of the game and a choice. Like, there's a slight difference between them, right? um Two pointers, I can say, maybe binary search, sorting algorithms. um for example, I can talk about the tree problems, right? We recursively call, and we have some rules before, like a pre-order and post-order. Like here, we don't pick a choice basically. Like, there is no optimal solution or choice, so we explore all of them, right? Maybe this one. Which algorithm or kinds of algorithms are not created? Three algorithms, I can say. Like, this is a good question. I'm really thinking about it. um but if we don't have choice, then they are not greedy basically. If we don't have multiple choices or possible, choices, paths, they are not greedy. And as an example, I can give you this. Here we like discover like a left subtree and right subtree, but they don't have any precedence over each other, right? We just explore them. I mean, but most probably there should be a difference between like a having two paths, I mean, two ways to discover, right? And two choices to discover. That's a good question actually. TV Josh, my friend, asked me a wonderful question about the idea of greedy. What kind of problems we can count as greedy? For example, I know greedy and dynamic programming share a common place where we have multiple choices, right? And we explore them. And in greedy, one of the choices is has some dominance over others, and we pick them. But in DP problems or backtracking, we literally need to explore every possibility. All right. But now the question is, what is the remaining of greedy and dynamic programming? Like which algorithms we can count as greedy and which algorithms we cannot count as greedy? Like my answer for this question is, um, I mean, maybe like three algorithms might be, not greedy because like there are two, like we call for left subtree and right subtree, like. mm, but there must be a slight difference between like having two paths to discover, and they don't have some precedence over each other, right? But you may say also, since we have like a two paths, literal two paths, maybe it is greedy too, but like we cannot call greedy even though we have multiple options. We cannot call it greedy. So what is the difference? And yesterday while we are studying, we distinguish having multiple options versus the game, like the rule of the game, right? So basically, not every if means option, right? Could you please clarify on that and create a note in our, I mean, create a note in our website with the timestamp. That's a good question, and my answer is like this. TV Josh, is it sufficient? But that was genuinely a good question. Like, thanks. Because basically, like, I mean, if we see a if statement, that doesn't mean we have some options, right? We should distinguish. Yesterday we have talked about it too, but now that you ask again, it made me think about uh, this again. From TV Josh, he's a discriminator. Um, Choices. What differs is how you are allowed to resolve a choice. Alright. Greedy. Pick the one dominant option, commit, never reconsider, yes. Exchange argument, yes. In DP, try all options, yes. Backtracking, yes. So, your left subtree, right subtree example is divide and conquer tree recursion. Mm, and it is the cleanest proof that multiple paths does not mean don't mean greedy. You don't pick left over right. You need both to merge them. Yes, so you should. So maybe it is more similar to DP than greedy. Greedy will throw one away. So one your sharpest insight is not every if is an option. Correct. There are two kinds of branches: rule branches, mechanics, mhm, and decision branches, real choices, genuine alternatives where you must choose. And only here can dominance have even apply. Yeah. Grid only lives in decision branches where one alternative dominates. Alright, so this is the answer. But so the litmus test is there a real choice or just a rule? If a real choice, does one option probably dominate? Alright, so For greedy, we are trying to find, I mean, in this problem, we are trying to find an option that dominates other. Um, and here, for example, in three problems, we should basically explore both branches, no matter what. And they don't have any dominance over each other. Yes, like this is my answer basically. So this is not greedy, but it was a good question. Um, all right. Hmm. So now we can. I mean, I can talk about. I mean, we can talk about. We can discuss about exchange arguments. So thank you. Now I need you to show me some exchange. I mean, show me exchange argument logic. All right. On some other questions. All right. Don't give us hints for this problem, but I genuinely need to internalize this exchange argument thing because I don't want to do um, like a case analysis. All right, I hate it. Um, so can you please show some examples, and maybe you can even create some PNGs. All right, uh, because what is O, what is G, and how am I supposed to implement that idea in every greedy problem? Like how do I define uh, what G and O are or is? Let's see. It actually answered this question before. The generic idea of an exchange argument, the part that transfers across problems. So you never construct the optimal answer directly. Instead, you say, suppose someone hands me an optimal solution. So, like this part is triggering my intuition of recursion. Suppose someone hands me an optimal solution. If so, so actually my question now is like, how do we define optimal solution basically, right? For example, for in this question, like let's say like optimal solution here is like this, right? So someone handed us this, right? This is optimal. Yeah, then what? Then what? If it disagrees with my simple rule at some point, what is your simple rule? I can exchange transform it one step toward my rule without making it worse. If every disagreement, like we should create some disagreements, guys, but I don't know, can be ironed out for free. Your simple rule must already be optimal. The unit you track is wrongness. And each grid action, oh my guys, like I need to see some visuals. Give us some guys. This is the most valuable thing to internalize for greedy. An arbitrary optimal solution. You don't know it, you don't construct it. Mm. An adversary hands it to you. The only the only thing you are allowed to assume it is optimal. Alright, we don't even construct it. Forget about constructing it, guys. G, the solution your grid rule produces. Determines deterministic. Alright. The solution your grid rule produces. Like we have two solutions. What are we gonna do about it? The move transform zero step by step toward G, each step an exchange that keeps it. Oh my gosh, still valid and no worse. So basically, we need to determine G and O. I don't know how to do that. Um, can you open them for me? Let's see. Let's see, guys. So the exchange argument, same skeleton every time. Any optimal solution. Like, what do you mean by optimal solution, and what do you mean by greedy solution? All right. I mean, like in lead code, there are some inputs and outputs. All right. So basically, you are saying that like I should focus on the output part. I mean the answer part or the expected or the the solution basic, right? And pick it, and then what? Changing some part of it, like adding some character or something like that, or changing the definition or changing the input. But I guess it is not about input, because if I change the input, for example, example case, all right, like that wouldn't mean anything. By optimal solution, what do you mean? Mm, every arrow keeps it. All right, so could you please clarify? Let's see. Maybe I should move it here. Maybe then we are gonna see. Yes, that is strange. So it should be in the same screen. All right. Um, but how would it know otherwise, right? So I understand your voice, Ink. So every arrow keeps it a valid and no work. So adversary hands you an optimal solution. You assume only it's optimal. What's your grid rule? Like I don't know my grid rule. And also like in the first image, you are telling us that like I can kind of understand O like an optimal solution, but I don't understand like G. Like you are telling me that what your grid rule outputs. Like I don't know what my grid rule is. I'm trying to find it, right? So I thought like applying the exchange argument idea will give us, I mean, will guide me to find that grid rule. But you are telling me that I already know like a G, right? Um, could you please clarify on that too? But I guess you are correct, because on web I've seen that exchange argument is for proving, right? Proving the correctness of an algorithm, basically, right? But my goal, like I thought, exchange argument idea will help me build that greedy, because finding that trick is kind of hard. All right. Like I mean, for some in some cases it is easy, and like for example, what might be the greedy here? I mean, swapping the first one. I mean, first one or the second. I mean, the close, or maybe we can create two different queues. Like the last question we have solved yesterday was using this approach, but I don't think it is the way. Like queue of ones, queue of zeros. No, no, no. Like we cannot do that. Maybe the position, like the number of ones and zeros, like of course they matter, but there is also another thing we need to care about, we need to think about. All right, it is the position of them. So how do we, like, we need to take the positions into account, basically, right? um so I should swap. By swapping, what do we do? What do we get? And what does it promise to us? Do we know it? So yeah, and also create another entry for this problem. uh it's about like I'm trying to figure I'm trying to figure out um the I mean, what do we get from swapping? All right, by swapping, like what does it promise to us? We don't know it. So add this question into our website, all right, with the timestamp. Yeah, hint would be great. If I have the optimal solution? Yeah, like hint would be great. Like you can send it, we can see here. Use hint comment. um, like people say grid is kind of easy. I should focus on the implementation. But for example, in this problem, maybe I overcomplicate it. Um, we'll figure that, guys. The cons are important, like of, but that might be one of the aspects. Like we cannot solve this question only by looking at the count, because, for example, like the count of ones and zeros in this case, and let's say in this case is same, right? So counts are important. Maybe I can make use of some frequency, right? But what I mean is that, like, only count is not, that does not won't help us. Only using the counts, I should have something more. Should we use stack or something, guys? Like, I mean, no, stack won't help us. Like, let's see. All right. So the correct answer is great confusion to surf it. Let me untangle it. Because you actually half figured it out, figure out yourself. What is optimal solution O? Not the lead code example output, not the input. O is the best possible answer arrangement for a given input. Alright, I like this. A full solution object. Yeah, so the optimal is, like, in this question is this, like, this is our optimal, guys. Alright, so what are we gonna do about it? What are we gonna do about it? Yeah, so maximum size, you don't know which one it is, you just say assume a best one exists, call it 0. It's abstract on purpose. What is grid solution G? G is a solution arrangement. Your grid rule produces, yes, but we don't know it. G and 0 are the same kind of object, both are subsets, both are orderings for the same input, for the same input, for the same input. Alright, so you can compare them by quality. Optimal is the unknown best. G is the one your rule builds. Your big realization and you are correct. Exchange argument is for proving correctness, not for building a rule. Yes, exactly. This is a thing to internalize. The exchange argument is verifier, not a discoverer. Oh, I thought we have something like a discoverer. To even run it, you must already have a candidate. Oh, alright. So now I am disappointed. So where does the rule G come from? The one exception where exchange does help you discover. For ordering problems, the proof runs backwards into a discovery. You say swap two adjacent items x and y. For Goody's order to be best, swapping them must never help. Forget about exchange argument, guys. We are all alone. How many total possible solutions of ones and g's exist for any given string? So how many possible solutions? So like a permutation, basically. Like we can order them. We have 6 characters and 6 factorial, I think, right? We can, yeah, we can order them this, right? This amount, 6 factorial. This is our upper limit. We need to eliminate these huge possibilities. Um, Apparently swapping some indices, not some indices. but we need some indices at the end. But finding those indices should be some greedy maybe, right? Let's say, I don't know, guys. Let's say 1 1 0 0 0 1, right? And we need alternating, right? So like these are constrained. So after using a 1, we need a 0. So, but if we have 1, like we should swap either this one or maybe the previous one, right? And swapping it with which 0? So maybe I should focus on, like, should we swap this one, or maybe it won't matter at the end, but maybe the important part is selecting which 0. How about selecting the first 0? Oh no, they need to alternate. Yes, yes, they need to alternate. Yes, yes. um so let's pick the first one. All right, for example, when we see a reoccurring character, all right, item, let's say this is the prev and this is the current, right? And current is same as prev, so we should swap it, right? Maybe we can store the addresses of each 1 and 0, but like swapping should promise me something. I mean, swapping promises us that we're gonna get rid of this one and we're gonna have 0 instead. All right, if the prev and current is same, if we swap this one, we don't know which 0, but let's say one of them, or let's say the closest one. All right, let's swap it and let's see what we have. 1 1, I mean not 1 anymore, 0 1 0 0 1. So, and after swap we can move. Where should our pointer go after swapping? To the next one. So now our current here and our prev is this, right? And then we can move it one more. They are alternating. One more. Now they are not alternating. So let's swap with the first opposing one. I mean, if now, since the reoccurring ones are 0, we should focus on finding the opposing part, so 1. How about this, guys? Like, now, maybe now exchange argument can come handy, all right? Because now I have an idea, and maybe interviewer may ask, like, "Are you sure, my man?" Right? Um, and we need to prove that. But all right, so now we think that hmm, we think that um like we have an idea, right? Just swap, like when we hit a reoccurring one, like a neighbor, not alternating ones. Let's swap them with the current, I mean the next or the closest opposing one. Let's say if we have not alternating zeros, pick the closest one, I mean closest one, and swap them. All right. But now I guess this is this is this can be this can be where exchange argument idea can be handy. All right. Because now if I prove that without doing case analysis, then I could start solving the problem. What do you say about it? How many correct alternating strings are there? Yes, I guess so. Um, that's a good question, I think. Yeah, yeah, yeah. So, I mean, it can start from start with 0 or 1. I guess there is 2, right? That's a brilliant question. I mean, if we can either have this or like a 3 0. No, actually the number now matters. If we have even number of elements, um we have 2. Yes, only 2. Yes, if we have even number of elements, we have these 2. That's good. Like, that's a good observation. Like, but I need to make this observation by myself. Like, thank you, by the way, you are amazing. But that is good. I mean, that is good. Like, this is I feel, I sense that this is the core part in this question, like making this observation. But I didn't do it. But we can continue. We can continue. So if we have even number of elements, these are 2. But if we have an odd number of elements, then things got a little bit messy. But of course, like, even making this observation, like, it doesn't finish. So I can continue. uh, so so that's an observation, but how does it help us? um, so let's say we have, I mean, this one, and we know that we're gonna either have this part or that version. Oh, we can count. We can count, right? um I mean, what do we count? We can count, for example, let's pick this path. All right, this is 1, this is 1. All right, this is 0, this is not 0. Let's increase the counter by 1, right? But now it has its pair. So when the next time we see a 1, we shouldn't increase the counter, like something like that. Yes, something like that. So, like, let's say this one is 1 1. So move. This is not same, basically. We assume that the answer is this, right? But, and also I feel like at the end it won't matter if we pick this one or this one, so that we count any of them, and we will come up with a solution, right? I i i sense this, but this observation is good. This is something, I mean, all right, we're gonna figure it out. All right, we're gonna figure it out. So, but I didn't think about, actually, I should have thought about it, right? Because although these are not our options, maybe I can ask AI what should trigger me thinking about these. I mean, for some problems, I think about the decision tree and it guides me, right? Seeing all the options and which part it collapses, it really helps me. But here, for example, in this question, drawing decision tree doesn't help, but instead focusing on the possible outputs. But there are some other grid problems where you shouldn't try do case analysis, right? But actually, we didn't do case analysis on input side. Input side, we've done case analysis on output side. All right. So this is 1, this is 1, this is 0, this so when mismatch, we should increase the counter, and maybe we can use some sort of stack or something, right? Why? Because, I mean, we are gonna swap this, right? We're gonna swap this with 0, basically. So this 0 will come here and 1 be here, and when the pointer comes to 0 1 2 3 4, like when it comes to 4, 0 1 2 3 4, when it comes to here, it's gonna see, right, 1 not matching is not matching with 0, but we shouldn't count it because we already swapped it. So if we find if you find a mechanism for this part 2, then it's gonna be done, guys. It's gonna be completed. How? Most probably, like, we can focus on the input side. I mean, no, not the input side. This is the possible. So anyway, so think from this side. Matching doesn't matter. Here is not matching. We increase our counter, or we swap, right? And we go this one. It's matches, amazing, and it matches again too, which is more amazing. And now we have unmatching case, but we already swapped this. Now we shouldn't count. So basically, but we swap, but uh, maybe we didn't swap with this one, but maybe this one. How do we? Maybe we don't need to know which ones we swapped. Yes, we don't have to do that. So we assume it works optimally, right? So basically, we should focus on if mm, if so basically, if our character is 1, right? And if it is not match with the our possible thing, like a possible outcome that we have chosen, if it is not, so if it is 1, let's say we increase the counter, all right? And in next time it's gonna find mismatch, we know that we already fixed it, right? So it's gonna be some cases like 0 is not equal, I mean uh is not equal to 0, basically, all right. So we shouldn't increase the counter because we already swap. So maybe after increasing counter, right, we can decrease. Maybe we can have another parameter, right? Let's create another parameter. Let's call it decrease for 0, right? All right, and increase it 2, right? And when you find something like a 0 and unmatching, and if you have like a decrease for 0, you basically increase the counter and decrease by this one, so it doesn't change. How about that? Like, this seems legit. Now I can try coding it. But this was, I think, core observation, thanks to TV Josh. Observation, right? And I assume that picking either this one or like this one or this one won't change the result, so we can select either of them. But this is for even case. We should also care about the odd case. For example, our input can be, I mean, like this one, right? Uh, and maybe in that case we can start our optimal, actually. Uh, Actually, these are optimal. There are optimals too. Like, we have two optimals basically, right? Two different optimals. Uh, so here maybe our optimal, we can start with 1, right? We shouldn't start with 0 basically. Yeah. So for even case, we can just start with whatever we have in our input. Like if our input starts with 1, we make our optimal solution start with 1. Or maybe we should start with make it start with 0. Maybe we should try two branches and take the minimum or minimum, because for example our input maybe uh, I don't know, like I don't know, but this is my feeling. So let's see. uh, what do we have? Minimum swaps. Oh my gosh. So we said that we have two uh, correct alternating strings, or there are only two correct alternating strings possible. Core observation. We can, I mean, we can get the length of the string, and we can generate uh, gener I mean, if the length is 6, we should generate. I mean, if it is even, hmm, if it is even, we should generate something like 1 0. I mean, 1 0 1, something like this, right? But also, we should prove that making it start with 0 does not give us any better or worse result. Like, we should prove that. I didn't prove it yet. I just assumed. I just hoped. All right. But most probably, maybe like maybe we should try each of them and maybe take the minimum. I don't know. Like there is some open part, unclear part. Stringlet s length. So we should generate something, right? String generate. So we should get an integer, and we should generate, but we didn't prove it yet, but maybe we should prove. Anyway, without proving, let's try typing, and then we can read the AI response about exchange argument. So how do we create an alternating I is small, not I, make it A, smaller than A. So maybe we can make use of string builder again, right? It is safer for us because it generates us, because it is mutable basically. That's why we can like append, right? Append what? Let's append if I is if it is even, we can do something like that, right? If it is even, if I is even, let's append 1. If it is not, let's append 0. And then convert it. Convert string builder to string. But of course it is for even case. I mean, if A is even. If A is even. We should think something else for odd case. All right, we are now generating our string. Generate. Oh, should I define it above? Like, it shouldn't matter. But let's do it. Generated. That's interesting. Maybe I should use like this. Actually, no. Why? Our method is static. Public. Let's make it static too. Oh my gosh. Anyway, let's call it generate string. But I don't want to make it string static. So call it. So now we generate alternated s. So we have it. All right. So now the remaining part is easy. So we just check one by one, and we're gonna have a counter and decrease for 0, right? All right. Integer counter for 1. All right. And integer decrease equivalent. Decrease corresponding. Corresponding. How about that? So integer I smaller than a slang, I think, right? Yeah. So if they don't match, but we need prev and current basically. It's been 1 hour. Oh my gosh. We should also be able to solve these questions under 1 hour, guys. That's another constraint for us. Even maybe like in 45 minutes. But we'll get there. We'll get there eventually. Like we are gonna compare our input with the optimal one. Our input. What is our input? Our input is s. If s character at I is if it is not matched, do we need to know if it is 1 or 0? We don't, but when we let's say like this is first mismatch, all right, we swapped, and when we have another mismatch here, right, here we shouldn't count this as mismatch because we already swapped that. So first mismatch, so if the mismatch was with 0, and if the next mismatch is 1, we don't count it basically because the previous was. So um so when the mismatch is alternating, you don't count it. Don't count the next mismatch, but that mismatch should be with the other. How do we do that? If the character in our string, I mean input string and alternated string is not matched, we can increase the counter, right? But that we should also hold our prev, or forget about decreasing, right? But instead prev, I mean like we should have a mechanism for detecting, for understanding mismatch type basically. Is it 0 1 or 1 0? Because when we hit another mismatch, right, we are not gonna count it. So like we need such a system. We need such a system. So we shouldn't increase this counter. Actually make it counter. Right? We shouldn't increase this counter right away, but first, before it, we should make sure we, we should make sure it is same, or we literally need to hold the information about previous swap and source of the previous. I mean, let's make prev not integer but character, and if prev is not prev is empty, right? If How do we check empty character? If, of course, it is not empty. If prev is null, I think, right? How about that? Now, right, that I don't know. If it is null, then we set prev to our current character and also increase the counter. If it is null, if it is not null, meaning that we have a previous, then our previous character should be same. If it is not same, we shouldn't increase, so we can continue basically. So if it is same, right, if prev is same basically, right, we can just continue. We shouldn't increase it. If it is same or different, let's focus on that. If it is different, yes, if it is different, we don't note that because we already change it. Yeah, like we can, for example, here, like we, like this is good, we advance. All right, these are same. These are mismatched. These are string, input string, and we have one, and there is mismatch, and we should swap. What do we swap with the next, like closest next different closest 0? Actually, we don't change with the closest one, but let's say with the optimal one, all right? because the question asks the number of swaps. It doesn't ask us, oh, that's the crucial part too, guys. It doesn't ask which one to swap. So we assume our program swaps optimally, and it is kind of strange, guys. Like it is like a recursion. Like we don't know how we do it, but we prove it works. This is kind of strange. Actually, we can create a node. So now create a new entry about similarity, resemblance between recursion and grid. In this problem, like at the moment, we are trying to like create a code where we just when there is mismatch, we swap with the optimal one. Like we don't know which one, all right, but we assume that our code works optimally and picks the correct one, right? uh, and now I'm trying to prove that it works basically. So I felt like recursion idea and grid like resembles to each other, all right? Because in this I also realized that this question doesn't ask which one we are swapping exactly. It doesn't ask us their indices. It is asking us the total number of swaps, like minimum number of swaps. So as it says minimum, so we say that this is the optimal and it picks the correct ones. But actually there are some other grid problems where we need to, for example, water with like a container with both water, like we literally type the code where like we move the smaller height, smaller bar inward in each type, in each step. So that was different, but here we don't pick those indices exactly, but instead we count, we increase our counter. Could you please clarify on that and create an entry so that on YouTube we will have timestamp? All right. Let's see, guys. Come on, come on, come on. So when mismatch, so when the next, like, so we set our prev here, right? We prev now is 1, and when the mismatch happened again, our prev is 1 and current is 0. So then we shouldn't increase counter. So apparently they should be not same but different. If they are different, we don't count. We don't count. Should we update the prev again? I guess yes. Update with the current character. I guess we should update it, right? Let's see. Let's see what would happen if we have another mismatching character. Let's say 0 and let's say 1. All right. And our prev is 0. We didn't swap or count, and here we have again mismatch. What should we do? And also there is no other character we can swap, so we should have a stopping case, and also we should have a mechanism for recognizing that we now reached the end and all of them matched or not. So because by the time we hit end, we don't need to process the last element basically. By process we are not gonna do, we are not gonna apply swap operation at this index, but we of course should check if they are same or not. So maybe we should add base case, like not base case but maybe stopping case, if the I is equal to S S length -1. Now we are at the last case, and if they are not matched, we return -1. If they are not matched, so if the character at last index is not matched, with what? Alternative strings character. So I guess I need to change this here too. If the so we should also have something like this here. If the last character of these two strings are not matched, all right. Mm, but maybe they are swapped. So since we don't do some dynamic, changes, maybe they are not matched, but we maybe swap them. Maybe they are swapped. So basically, we should have uh, some sort of flag. So our system should have some mechanism to count. Maybe we can do one pass and see how many swaps we should do, or rather, then we need that. So do one pass first to see how many swaps we need to do. All right. Because we cannot just compare the last element, and if it does not match, return false. Like we cannot say that. But when we hit the end, uh, so actually we should have something like a countdown. All right. We can count the total number of swaps we need. Actually, if we do that, I mean, if we can do this already, then there is no need for us to do here. I mean, if you know how many swaps you need to do by one pass, oh my gosh, guys. Hmm, I need a break now. What do you say, guys? Like I was literally trying to calculate the total amount of swaps we need to do. Um, and then I realized that at the last index, maybe we shouldn't do anything. But imagine at the last character, there is a mismatch, and we are gonna try like increasing counter, but we cannot do that, right? We cannot, because it is literally last index. Hmm, that's interesting, guys. That's interesting. So, like, this question is good, and still we don't know if our assumption is correct or not. I mean, we said that picking this one or this one won't make any change after all. uh, Maybe, guys, it is simple than that. Like, all thing we need to do is just to compare. like like it should be simple than that. So since we made this observation, like, this is one way, right? All right. Like, but what am I trying to do is, checking them basically. Actually, yeah, I'm doing that too. Like, I'm not doing something crazy. Let's say this is optimal, and this is our, let's say, string, right? 1 1. I mean, 1 1 1 0 0 0. So, mismatch, increase counter. There is no I mean, match. It is okay. It is okay. It is okay. Mismatch. We cannot just say increase counter. Um, because we swap. So if we swap these two, then we are done, right? So like we need a mechanism, like a basic for loop, comparing, like literally comparing these kind of. Forget about prev or something. Like why do I have something like prev? Um, so if there is mismatch, so actually we are doing that, guys. Like we are literally, comparing each character, and if there is a mismatch, like, how about we just increase the counter? But we cannot do that because next time we see, yeah, we need this, guys. We need this. Like, I'm not crazy. We need this prev information, right? That's why we are, you know, bothered doing that. We need previous information. At the time for the mismatch, if the previous mismatch is different than current one, don't increase it. This is what we need to do. This is what we need to do. Come on, guys. So at the time of mismatch, just set the prev, right? And increased our counter. And so this, for the first time, if it is null and it is mismatch, we just swap. For the next time, if I mean our prev and current character is not same, meaning that, like literally this example, we shouldn't increase our counter bit. Actually, we done something correct. I mean, um, and we update our prev. But now another case coming up. How about the mismatch is at the last character? So like we need to, like, this is correct apparently. But how about the mismatch is at the last index? So we should handle this carefully, basically. How do we do that, guys? If there is a mismatch, 1 0 0 1 1 0 1 0, so the mismatch is here. So we swap. So when the next mismatch is happening, mm, we won't counter, but we can't count. I mean, we cannot increase the counter, right? And also, we need a system for understanding we reach the end without an issue or not. How do we know? Because there can be some case. Uh, I mean, like a impossible. That can, like, impossible is possible, basic in our case, right? We should be careful about it. So, how do we know we swept them correctly and we don't have an issue? Some sort of flag, maybe. like while we are counting our swap. So then I thought about, how about we calculate the total swap? But then I thought, if I can count the total number of swaps that we should do, then why bother doing these? They kind of overlap, all right? Like, uh, how many swaps we need to do? Like this is how we count how many swaps we need to do, because you cannot just count the mismatches and say this is the total amount. Actually, yes, you can do. No, you cannot. You cannot. Or can you? Let's count the total number of mismatches. All right. 1 0 1 0 1. Right. Let's count. Let's count this. Match, mismatch. All right. So 1, right? 2. So do we have 2? But here we need 2 swaps, not 1 swap. Yeah, total number of mismatches does not tell us the total number of swaps we need to do. Yes, definitely. Otherwise, it would be easy. Like, I will give 2 minutes more to myself and then take a 15 minutes of break. So the thing is, like, we have like a case for, how about last index mismatch? We don't have any opportunity to swap. Like, we don't have any number, we don't have any available character in our belt to use, basically. So, but our code doesn't care about it, basically. It just, when it's so, but it works for the left side. I mean, for each indices where it is not last index. But if it is last index, actually it has also something to do with the recognizing if we have a possible solution or not. So if we manage to find a way to recognize if we have solved the question or not, how do we do that? How can we know it is possible or not? I don't know. Let's read what we have in AI. Like, I can give up here, guys. I want to solve because lots of problems. So from this problem, I learned like this observation, all right, and this is the two optimal cases, because without knowing this, I cannot start it. Now I start coding, and now I got stuck at this part. Oh my, there are different levels to that. The only linear to take with recursion leap of faith. Counting goodies assumed optimal pairs correctly. Just tell it. You got prev started. Yeah, you are now measuring how far S is from alternating. Keep going and run it. So you have found a real fault line inside grid. Let me name it. 2 kinds of greedy. Constructive greedy. The algorithm executes the choices. You literally move the smaller. Counting and existence greedy. You never execute or names the swaps. You assume an optimal swap assignment exists and you only count its size. Oh, why this resembles recursion, and you are right that it does. It's a leap of faith. the induction hypothesis. In recursion, you trust that, yes, return the correct answer without tracing how, only combine at the top level. In counting greedy, you trust that optimal swap pairs think correctly without tracing which. You only tally. Saving the note. What licenses it here? The problem asks for a count. Minimum number, not a witness, yes. When the question wants a number and the structure has a closed form, you can skip construction and just count. Container with most water also returns a number, but it has no closed form. You are forced to simulate. Alright. I really like constructive grid and counting existing grid. Oh my gosh. I really like these two. Did you add these into our website notes with the timestamp? Let's take a screenshot and paste it here. Yes, it is already there. All right, so I see we started coding. What I need is actually now what I need is that like TV Josh showed us amazing insight, which is knowing that we have only two possible optimal solutions, right? I mean, for the, let's say we have like a 6 number of items, right? Oh, but in that case we need to know the number of ones and number of zeros too, because it doesn't it isn't about because I thought like we have only two different possible outcomes, but this is for let's say 3 ones and 3 zeros. All right, but if the number of ones or zeros changed, now the optimal one will change too. So what do you say? No, I didn't get the solution. I got stuck at this part. I mean, I tried to create this code basically, right? When there is a mismatch, I increase the counter by 1, but for the next mismatch, right, which is different one with compared to previous, we don't increase. So I created this now code, but then I realized for the last index we should have something different, or because at last index we cannot just swap, and I got stuck and I was about to take a break. So this is how far I could go basically. But and then also like I realized that the numbers of ones and zero also matter. Every swap is 2 mismatches. Like it changes, but I mean, so since we are doing it optimally, but are we sure about that? I mean, maybe we can swap and, for example, here, oh, even here it doesn't, it isn't the optimal case. Like there is a mismatch. Because this is optimal, forget about optimal. Like we should, yeah. So it works. Swap this one with this one. So we don't care about which one to pick. I only check every other character. Every swap is 2 mismatches. So actually what you mean is, I mean, like these 2 mismatches, but also like it is also important, like since it is 0 and it is 1, like we should count this as 1, because in one swap we handle them. But for example, if it were 0 here, right? Not here. Oh my gosh. I don't know, man. I just need to take a break. I only check every other character. I only check every other. What do you mean by that? I mean, let's say we have a string, right? 1 1 1 0 0 0, and the optimal one is 1 0 1 0 1 0. So you said that every swap is two mismatches. I mean, there is a mismatch here and mismatch here. So now we only need one swap here. One swap, 2 mismatches. But what if you only check every other character? What do you mean by every other character? What if you only check every other character? I mean, they are match, 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 and we have 2 mismatches. So you say that, I mean, if let's say we have another mismatch, these are string, right? And make it 0. And again we have a mismatch. Should we focus on the number of mismatches, and if they are even, then we got. If it is odd, then we cannot have a solution. Is it the answer? Since since you said this, there is a mismatch. Like these are string optimal. In our string. So yeah, like that can't be a possible. Like this should return -1, because that can't be a possible solution. So if we have even number of mismatches, I first make sure. So if we need to make sure that solution is possible, then we should have even number of mismatches, right? Yeah, yeah. This is another observation, because when you swap something, like we have a 0, let's say we move 1 here, so the neighbors should also correct, appropriate for us. So interesting. I'm gonna take a break, man. My brain doesn't function. Maybe 10 minutes break, and I'm gonna continue with AI. Yeah, later. uh, I thought like we have one check possible outcomes. All right, let's take a 10 minutes break, or make it even 12, guys. See you after the break. I was almost late, guys. Like last 30 seconds. Now I'm back. Where were we? We were suffering right, suffering right in the code. um, let's close them, shut them off, guys. We were suffering, all right. It was like, it was like a not torture, guys. Like, be positive, all right. Send positive energy to to the universe. Um, so maybe I can just decrease this a little bit. Yeah, I guess this is better. Um, so we figured that, oh my gosh, like we figured that there are only two possible optimal solution that we seek, basically, right? And I don't know, guys. Like, I guess I just got tired of this question. I wanna skip, but let's read it. So exactly right. Unless the missing half of TV Joe's inside, two patterns are only the candidates, but the counts decide which are actually reachable. Hmm. So one of them may be unreachable. So we can focus on maybe reachable one. Alright, alright. If there is reachable and unreachable, we count the reachable one. You can only ever rearrange what you already have. Swapping never changes how many ones and zeros exist. So this is what I'm talking about. Not this is what I was trying to tell you guys. Um, what does swap to do to us, right? We need to answer this. Like, by swapping, the count of ones, zeros, and ones doesn't change. Uh, this is an observation, so basically, so a target is reachable only if it has the same number of ones as s. So a target is reachable only if it has the same number. Hmm. Yeah, yeah. Like, I was doing something like this, and I figured, like, we have figured that, guys. Uh, the number of ones and zeros, like, important, right? And and then we realized that. Actually, we didn't realize that. We didn't say, yeah, yeah. So if the length is 6, right? This is one of our candidate, and the other one is this one, right? But in both of them, we have 3 ones and 3 zeros. Like, we had to, like, I had to make this observation. So if our string has, like, let's say 4 ones, then it is actually TV Josh tried to warn us and tell us about this, but we couldn't manage. That's all right. That's all right. So, like, I don't know. Maybe I'm making this question harder than itself, but eventually we will figure it out. All right. Because, for example, we also realize that, like, this is not constructive grid, but a count grid. So, and also, in the beginning of question, like, I didn't try finding indices of zeros and ones. So that's a advancement. That's a good sign, right? We are improving. That's a good sign of improvement, right? Not enough for solving the question, all right, but we should be positive and believe in ourselves. We'll get there eventually. This is a count grid problem, all right. And so we have only 2 optimal candidates. So this is a good observation. Uh, yeah, yeah. So, all right. So now I wanna go, like, a study. I mean, I wanna go solve another problem. Now wrap up. list the headache points, I mean pain points, and wrap up and summarize our thought process. And now like I took a break, and now I'm back, and now I realized that we I mean I didn't make this observation, the following observation, which is like if the length of the string is 6, we must have like a 3 number of ones and 3 number of zeros. All right, so this is the correlation between length and the number of ones and zeros. So in our string, if we have like a different number of ones or zeros than that, we literally can return zero, I mean like -1. So uh so because like I was trying to find, I mean I tried like a drawing the string and the optimal one, and I was comparing each each items, and I tried changing like a one, I mean one of the ones to zero, and tried thinking or extracting some idea, but I couldn't do it. But it was easy actually. I mean, we should get check the length of the input, and like we already know the how the optimal solution look like. So we know that. So based on that, we are going to build a solution on top of that. And like this is the code I have written. It is not full yet. So like maybe in the next iteration we can focus on, but now for the sake of time I want to go on. So wrap up, list the pain points and everything. Thank you. So maybe guys, we can try solving another question other than greedy. Today I've seen a question from a streamer, and I guess it is a maybe we can solve one DFS and then one DP and then um continue our greedy problems. And that problem I think was this one, guys. Yes, so let's try solving this one. All right. I really wonder if what we are gonna do. So um so AI is cooking. So count servers that communicate. So you are given a map of server. So we can update the topic now. Count servers that communicate. All right. You are given a map of server center represented as this integer matrix, where 1 means that on that cell there is a server, and 0 means there is no server. Two servers are set to communicate if they are on the same row or on the same column. All right. Return the number of servers that communicate with. Return the number of servers that communicate with any other server. For example, this one cannot communicate another, so it's 0, and this is 0, so summation is 0. But here, for example, this one can communicate with this one, which is 1. So this one can communicate with these 2, and this one can communicate with 1. So 1 2 1, we should return 4, but we return 3. Why? All 3 servers can communicate with at least no, we are not gonna sum them up. Like we need to count them. So I heard that I can use DFS here, but let's see. um so for example, this one can communicate with 1, so we can count, we can increase our counter. This one can communicate with this one, so 2. This one, yes, 3. This one, yes, 4. And this one, no. So the answer is 4. All right. Like this seems easy, right? I mean, like maybe we can hold, you know, for each row, each column and row. How about we set a flag, right? Mm, saying that there is a, because having only one computer is already enough. right? How about we select rows and columns, and if the coordinate of a column is I mean a row or column address or coordinate of a computer like a, is between in those rows or columns, we can increase our counter. So we can literally traverse, but we need to do this traverse twice in two pass. In one pass, uh like this is it, guys. Like I don't sense any dangerous thing about this question. Let's see what AI done has done. Session wrap up, thought process. Yes, yes, yes. Pain points, the index trap, exchange argument confusion, missed the length count correlation at first. Yes. Over engineered the one pass with. Oh, all right. Count mismatches versus a generated target. Oh my god. Like we need to. Alright, so uh, alright, so now I just started thinking about this problem. Now create or mark in our notes, alright? So the start time of this problem. Like I don't has anything like a like in two pass like a for loop like uh do we need to like optimize, maybe do something like that? I mean, without iterating every computer, can we have an answer? So if we need to iterate through all the computers, right? So I mean, I don't see any DFS or something here. I and J. Let's make it full screen. So we can have sets, right? For each columns and rows, or we don't even need a set. We can have an array, two arrays, one for rows, one for uh, rows, and one for columns, right? And we can flag. Um, but this is insecure. But this is insecure. So is there a solution? Is there a solution other than that? Let's try with brute force then. So I mean, we should literally process each computer. Like, don't we need? Because let's say if we don't process this, how am I supposed to know there is a computer or not? Hmm. All right. So let's say this is the answer, right? This is the correct approach, and our solution, our approach, tells us that um, flag each row or column after seeing the first one. For example, we see this one. Let's mark this row right away, right? I mean, row 0, right? For example, if we have, let's say, uh, like in grid, right? I and J. If it is 1, right? We can we can flag this row by 1, right? And for example, we can add a guard here if the rows I is 1. Oh, if it is, but they should, they should be close to each other. All right, so all right, so this doesn't mean I mean, for example, if that computer were, oh my gosh, come on, if that computer were um, here, for example, our solution, right, counts at, I mean, +1, because we have a computer close to each other. I mean, at the same row, but this, I think they should. I mean, they should neighbor, or that. So that is why DFS is the solution, because we should explore basically, right, the neighbors, looking at for direction endlessly. So because we can have some chain. All right. So this is DFS. Let's see the constraint for that. Like, I haven't seen it. Let's see the constraint. All right. So if they're on the same row or on the same column, but it literally says that, so we don't need DFS or something. Explanation: two servers in the first row can communicate with each other. Those servers in the third column can communicate with each other. The examples, in the examples, they are neighbors. But how about we have a computer here, right? How about we have a computer here? Can it communicate with others or not? Like, in the examples, we don't see it. You are giving a map of server center represented integer matrix, yes, where 1 means that on that cell there is a server, yes, set to communicate if they are owned by, like, the constraint doesn't tell us that, they should, one far away, right? It doesn't tell us that. So our approach should work actually. But even like, how does our approach work? I mean, if that row flagged, meaning there is a computer, like, should we increase the counter? I mean, so if the row that current computer is flagged, just can't increase the counter. If increase the counter and not continue, right? No, we cannot just continue. Increase the counter. So next iteration, if it's again increase. So there is no, like, if there is no computer at the same row, then we are looking for the same column, columns I. If it is 1, then we increase our counter 2. Because they communicate each other. So, but how about the first one? I mean, there is no. So we should do first pass to know the rows basically, right? In the second pass, so it is 2 times n square, like our time complexity basically. We need a first pass because here, for example, for this one, for the first computer, there is no computer at this row, so we place it, but we don't count the placement. We should count if there are some others. Mm, so the solution for that would be two passes. Because if we know there are some computers and on the same row, starting from the first computer, we can increase the counter. So we need so um, integer I is smaller than length of rows, right? Aymanat, hello, welcome in, Aymanat. Aymanat, was it you yesterday telling me that creating that voice commands? Was it you? Do I remember correctly? Welcome in. How are you? I guess you said something about voice commands. Then you said something about that. Yeah, I mean, no, I don't think. Oh, all right. But we have voice commands, so you can try it. Like a motivate, tease, miss, and push. Like, do you think that we need DFS here? I mean, let's. No, it didn't work. Oh, I need to add you to the trusted part. Sorry. Let me add you. I made you now. Yes, now try. Can you try again? Now you are trusted. Can you try it once more? Now it's gonna work, I suppose. I think this is. Yeah, you can now use it. I made you trusted. I assigned a profile to you. Now you can use it.
This is your table. The bug does not leave it alive.
Thank you, Aymanat. Thank you for the push. So, um, like, how is it? I guess it is fun. You can also send me some hints using hint command, and I will see your hint here directly. Yeah. It is really fun. Like, do you think we should use DFS here? I mean, I'm thinking. Uh, yeah, we. Hint is three dots. What do you mean by that? Yeah. Like yesterday, I spent lots of time for this after the stream. Testing. Yeah. Let's make it. Let's make it increase, right? We may need one pass, and also you can send your message like after the motivate. You can add your text here.
Ugh.
Oh my gosh. Like this one. I didn't mean to send this, but so it supports custom text too. Yeah. Like we have an edge case. I will fix it after the stream. Thank you. So instead of increasing, uh, if we have a one, let's mark it, all right. But I guess it is not the correct solution. So we just maybe should ask, but forget about like we can ask AI if it is if our solution is correct or not because it works in two n square time complexity. Like it doesn't sound cool. Uh, And if we look at the definition of the question, we don't need anything special. Like we just need to mark what we have. But like this question doesn't look. Actually, we can use grid, the grid first one, and then right, j plus plus, and forget about these parts. If if we have a computer grid I j, if it is one, let's mark that row to 1 and columns to 1, right? So this is first pass. So in the second pass, so again we need nested for loops. In the second pass, if it is 1 and either in rows, but we can count the same computer again, but it doesn't matter if the row is but the thing is, guys, the current computer can be the reason why that row is marked as 1. I mean, indicating meaning that there is a other computer. So how can we detect it? All right, maybe this is why we cannot use this. So I just copied that part, and now we are when the single concept. So now like I tried solving this question, and the solution we have in our minds is like having making two passes, right? In the first pass, we can mark the rows and columns, and in the second pass we can count the computers, right? But in this solution, we have realized that the current computer can be the reason why that row is marked as as 1. So this may cause some problems. All right, so I guess we need to find another problem, and I heard that I can use DFS, right? But when we look at the definition of the problem, it literally says two servers are set to communicate if they are on the same row or on the same column. So like they don't need to be like a consecutive or something, like neighbor or something, right? But don't give us hint, just tell if our logic for this like a brute force kind of thing is wrong, right? I mean, is right. Let's see. And create an entry about this thing, right? So now I guess, since that we now realize that like using this approach does not help us at all, because we cannot distinguish this. So what else we should use instead of this one? So yes, 0 or 1. Maybe we can look at some hints, but I wanna think a little bit more. Return the number of servers. So how do we know which computer, I mean, has some communication. So we should define the communication. All right. Like communication means there is another computer. There is another, at least one, at the same row or at the same column, right? Like like I can try applying DFS here, but what should push me to think? Because if I haven't heard using DFS, I wouldn't uh, think about it. The bug is what you store, not the structure. Now answer your own open question. What do you store at mark time so a server can tell whether it's alone? Your instinct is correct, and that's a sharp catch. Let me confirm exactly what's right, what's wrong. The two pass structure is right. All right. DFS is the wrong turn. Oh, all right. Your bug diagnosis is right. Yes, if you only mark presence, then a server that is alone in its row, its row still sees its row marked because it marked itself. So you would wrongly count lonely server. Yes, this is our yes. Um, so itself. So you wrongly yes exactly the trap you named. All right. So we don't need DFS. All right. So I guess that person told us wrong. So the bug is not in your approach, it is in what you store when you mark. I guess this is correct approach, guys. Now that we know. Uh, but how do we fix it? Rows this length, yes. No, length of this, right? Yeah. And this one is, let's take the first one. This is correct, right? Yes. All right. What should we do? If we have a, like now in the second pass, when we hit and when we see a computer, I mean, like we have the risk of saying that we have a communication with other where we shouldn't do it because that computer can be the only one in that row. um we don't think about the columns yet, but forget about columns for a second. And for the same row, at the same row, um like because in the first pass we mark this row as one, meaning that there is a computer in this line, in this row. But making this assignment has its risk, its own risk. Maybe, but how are we supposed to mark a row? How are we supposed to indicate that row has some computers? Like we need to store this information. We need this information because guys, like um let's say we have like a computers, all right? Let's say we are processing this one, all right? For this one, if we know that there are some computers, we can increase the counter. But if there are there is no any other counter, I mean computer here, we shouldn't increase the counter. All right, and we just need to mark that row and column for the future ones. Maybe we can look at the hint, guys. Like we don't, like we shouldn't spend that much. So store number of computer in each row and column. Store number of computer. Oh, instead of, like, I really wonder, guys. I really wonder, like, in the real interview, like a face to face, like, do we get this kind of hints? I guess yes, right? All right. So store number of computer in each row and column. So instead of storing the presence of computers, but what would we get if we do this? Store the number of computer. We can maybe know that in the second pass, um, it's been 3 hours. All right, we are in our 3 question. All right, so one problem for each hour. It would be great. It would be great. So, um, in the second pass, if we know how many computers we have, and in the second pass we can count it again, right? And if it is the first one, or if there is no any other computer at that row other than us, but if we store the number, then how are we supposed to increase our counter? Like, because here our idea is, I mean, if there is a computer, we just increase the counter, right? I mean, if there's a computer and if there are other computers, but now we change the representation of, I mean, showing other computers using the number of computers. We don't use the presence of other computers. We use number of computers. So what do we expect that number to be? What do we expect that number to be? Mm, and how do we fetch it? So like it is already integer. So if we have, so instead of assignment, let's increase the counter, right? So we count the presence of computers, right? And if the current one is, so basically, guys, we need, so let's say we have a computer here, right? Like we can be processing this one, right? And while processing this one, we know that there are 3 computers in this row. So if it is basically bigger than 1, right? If it's bigger than 1, we can increase it. All right, all right. If the number is bigger than 1, all right. So if there is a computer and if the number of computers there in that row is bigger bigger than 1, literally, right? We can increase our counter. So the representation of other computers, like, is, we change it. We change it from presence to number. Like I really like this about um about coding, actually. So this translation, like, this is literally, like a real, like a human language, like, because you can say the same thing in any like other languages too. uh all right, so let's create a counter, right? Let's create a counter. So if we have other counters, right, other than us, meaning that more than one, we can increase. If it is not larger than one, we shouldn't increase it. Yes, this is it. So uh, we can add, or like we can, oh, this is it, guys. We've done it, guys. We've done it. Oh my god, we are just amazing. Like, this is not greedy. And as TV Josh asked once, what questions we have, other, like which questions are, not greedy. This is not greedy. Maybe we can ask AI why this is not greedy. So we should return the number of, yeah, so this is the answer, guys. Let's run it. Come on, come on, come on. uh so we didn't add this one here. Now we are gonna see green. Oh my gosh, let's click on submit and see the amazing green color. Oh my gosh. So actually, this is like the fun part about this question is, guys, like this question was easy, to be honest. And but nice, thank you, Aymanat, thank you. The nice, like a cool thing about this question was like a representation. Like how do you plan to represent um the existence of other computers? All right, like you can use an array, obviously, but as AI said, what are you gonna store there? Like at first we tried storing the presence, like we literally like a 0 or 1, like are there others, yes or no, are there others, yes or no, but like we didn't exclude ourselves. All right, because in the first pass we literally like we were literally mm, making that row 1, even if there is only one of us, I mean only us. All right, but like in the updated version we store the number of uh, computers in the row, and now we are able to extract ourselves. All right, if there are some other computers, meaning that the number of computers is bigger than one, other, like if we are there, and if there are some others, then in that row there will be more than one computer, right? And in that column, apparently, I really like this translation. All right, I really enjoy. So now, all right, let's copy this part. And are you now ready, guys? Like now we're gonna solve dynamic programming question. All right. So thank you. Now you can wrap up. I figured we should represent the presence of other computers by their numbers. All right, because if we use only presence, like a 0 or 1, indicating there are some others or not, we cannot extract ourselves from those um, arrays, basically. So if we use the number of those computers, we can extract ourselves by using like a comparator, like a greater than one comparator. All right, I really enjoyed, like this problem wasn't hard, like it is easy, but the part that was fun to code is like doing this translation, because you can represent the existence of others using like a maybe even boolean, using array. So like there are multiple, there are many possible approaches. All right, I really enjoyed that part. So create another entry, mark it, wrap up, and we're gonna go another question. Like I'm gonna ask it to bring us a dynamic programming question. And actually I will make a web search, find the dynamic program question that is asked like a in recent weekly contest or bi-weekly contest. All right, we're gonna do this, guys. We're gonna do this. Actually, like in this question, guys, like since we were using like a zero or a zero and one, like it was literally like a boolean. All right, presence knowledge, presence information. Even though we use integer for that, it was like a boolean. um, we change it to number. um yeah, so now I need you to make a web search to find the recent ask dynamic programming question in the lead code contests. Like it can be weekly or bi-weekly, you know, in the previous contests. Because I wanna just practice dynamic programming very, very, very much. um like greedy is alright. Greedy is easy, guys. Like we are sharing some positive energy to um universe. Greedy is easy. We're gonna do it. But like I really enjoy solving DP problems, alright? Somehow it seems easier. But we're gonna handle this, guys. We're gonna get there eventually, guys, right? Alright. Alright. It also now created our node here. Yes. Yes. The real skill was representation, not all my. Like, look at these guys. Like I feel quite privileged having this sort of setup, right? Like we've studied a problem, and now with the timestamp, like we have it, and I'm gonna upload this on YouTube, and we're gonna have the timestamps there, and even like a clicking on this timestamp in this address. Let's say after one week, 2 weeks, when we review, like we will read and we're gonna click these parts and it will direct to the related part of the video, that video, all right? And we can see how we suffered, which mistakes we have done. Like this is a privilege, guys. Like look at it. Like this, it is just wonderful, guys. Like I figured, like since we stream like for long hours, all right. I figured that like uploading like a 10 hours long video like doesn't like isn't like a useful basically, right? Because it's too long and you don't know which topic that the author mentioned or talked about. But with these and with these timestamps, you can literally see the thought process. Look at it, guys. Look at it. We can maybe even add some colors on that, all right? um so that even reading it is gonna be easy. Oh my gosh, guys, this is just this is just amazing. And also you can see it too, right, guys? You can read, yeah, you can read what we have studied here. um let's see which all right, so which let's see which dynamic problem we're gonna solve, guys. I'm quite excited about it because DP is the ultimate goal in lead code. Like, of course, during the interviews they ask lots of questions, but DP is kind of special. It is special for me for some reasons. All right, one of them is it is related to recursion, and I love recursion. Let's see. So, best recent contest DP sources. These are exactly what you ask for. Recent Q3, Q4, the hard half of weekly Bible, where DP lives. Mm, the fresh test created completion. Hmm. A concrete DP practice set of real contest problems. Hmm. Since you want volume, here's a pattern organized starter. My suggestion: pick one pattern per session, pull 2 or 3 from that row, plus the same pattern. Want me to scaffold? Actually, let's click on that and let's see what we have here. One of the most effective ways to prepare online assessment is to practice the third and the fourth questions from recent literature contests, as these problems closely match the difficulty level and patterns commonly seen in actual. Below is a curated list of problems from most recent. Oh my gosh. Design ride sharing system. Oh my gosh, guys. Are we ready for this, guys? Are we ready? Oh my gosh. This looks ugly. But I want to make sure DP. Here we're going to use DP. Let's read it and decide by ourselves, all right? A ride sharing system manages ride requests from riders and availability from drivers. Riders versus the drivers. Driver. Riders request rides and drivers become available over time. The time should match riders and drivers in order. All right. Implement ride sharing system class. Initializes the system, adds a new rider with the given ride ID. All right. Add driver adds a new driver with a given. All right. Oh, we have two other methods. Match driver with rider. Matches the earliest available driver with the earliest waiting rider and removes both. Like we can use a heap and we can pick the earliest one. Or if we don't need to use heap because we can use array sort, because yesterday, as Lazy Skimmer said in his answer, like he literally used array.sort in the killing monster problem. I used heap. The driver with the earliest waiting rider and removes both of them from the system. Returns. Actually, the reason why I have used um, heap, like a min heap, yesterday's problem is that, like, because of the extracting. But extracting could be represented by like a for loop, and if you iterate from left to right, basically after moving, like after advancing, you literally extract them, basically, right? So these representations, is good. So matches the earliest available driver with the earliest waiting rider, re- removes both of them from the system, returns an integer array of size 2, where, I mean, if a match is made, if no match available, how come match is not available? Like, I mean one of them should end earlier than the other. Cancel rider cancels the ride request of the rider with the given rider if the rider exists and has not yet been matched. Let's see. Ride sharing system. All right, we initialize it. Add a rider, add a driver with the given IDs, like an ID with 3, 2, and 1. We have two riders. Whoa. And then, did we update the? We should also update. Anyway, let's solve this question, guys. I mean, I don't know how come it is DP. Oh, forget about this. Like, let's read it like this. So we initialize it. Rider 3 joins the queue. Driver 2, rider 1. So we don't need to know the time. We just like Q is good here, right? Mesh driver with rider returns 2 and 3. Like with this driver and rider. Alright. We add another driver. And then cancel rider 3. Rider 3 is already matched. Cancel has no effect. Before matching, you can cancel rider. But after matching, you cannot. I thought after even matching, we can cancel. But so we have cancel rider here. Rider 3 is already matched. Alright, cancel has no effect. Match driver returns 5 and 1. I don't understand why it is DP. I guess it is not DP. And if it is not DP, I don't want to solve it. Like, it is literally simulating, like using Q. Like we can solve this, but later, not now. And actually, since I didn't started my own timer, I don't know how many minutes passed. Yes, this one. Let's take a quick. First, I wanna find real DP. DP problem from lead code contests. Like, can we sort them by? Maybe the question ID will tell us. I wanna solve new questions, right? How can we do that? My goal is to find the recent, like a deep dynamic programming question, all right? The recency is quite important for me. Can you find us one? I don't care about the question 3 and question 4 in the contest. I need to have a DP problem that asked during recent contests. All right. Because like this question is quite good. I really like it. It is good. Like we're gonna solve it, all right? But like what can we use? Literally using a queue is good. Like I don't see anything different than if else statements, like, and using a queue. This isn't hard. There is no fun part with this. But of course, during the interview we should able to solve it. Let's see. Version 1 easier constraints. Version 2 harder needs an optimized DP. Contest 505 is the newest. So this is about the recent SDP, as recent as DP gets. Why it is a deep DP, not a Q3 throwaway. It generalizes a no lead code classic. The state is 2D. Found U1 and it's genuinely deep DP from very recent contest. So let's see. It is hard. Let's see. All right, we are gonna solve this question. All right, guys. Let me pause it and let me update the topic. All right, we're gonna solve this. I need to take a quick break, maybe like a 5 minutes or something, but let me set it 15 minutes. All right, I'll be back in most probably 5 minutes, but see you after the break. We are back, guys. We are back. We're gonna solve this dynamic programming question, alright? I'm excited, guys. I'm excited. You are excited. We're gonna do this. We're gonna do this. Back to work. Pomodoro. Let's see what we have here, guys. Wish me luck, guys. And also, oh, nice. Oh, all right. Let me. Good luck. Oh, welcome, welcome. How are you, lazy lobster? Let me also stop it and start it again. Let me make you trusted too, so that you can send some audios. Actually, all right. How are you doing? How are you doing? Like you can send audio comments. Great, just 3 hours session today. All right, I see, I see. Now I realize that I don't see your name here. If you don't try to send audio, this is kind of bad. All right, I need to fix it. So I created um a stream like a sound. You can create, like you can send.
Let the focus flow through you. The code bends to a calm mind.
You can send these comments, but sadly, you need to do this. You need to send first. Push. All right. Let me check. All right. Now I see. And let me make you. All right. Now try again. Try again, and now we're gonna hear your message.
You think it is fixed. It is not fixed. It is waiting.
Yeah. Thank you. Thank you. Um. Oh, three stream strike. Wonderful. Wonderful. Thank you. I appreciate it, Lobster. Like, yeah. Yesterday I spent some time. Yeah. Yeah. I created like using cloud obviously, but it is a local running Twitch daemon, and I have a local running voice model. I was thinking also creating something similar like Bongo Cat. Well, what is that? Bongo Cat. I guess it is. Hmm. Oh, I see. I see. As you talk, it moves. Steam game, but for Discord running locally. Hmm. I see. But I've seen this. I've seen this in other streams. Yeah. As you talk or type, it moves. I like this too. Like I also want to have a remote controller toy, all right, and you can ride it in my room or in the home. Um, but I guess we can do it some other time. But I have those ideas. Maybe some drone. All right, you can send a comment there, and you can um, you know fly it basically. Go back basically. You can see other type. Hmm. But connect the Discord directly. Oh, this is good. This is good. Oh, this is good. It is fun. Like, I can try this too. Yeah, it gives you some not authentication, but what was that word? Authentic, authenticism maybe. Um. All right, let's take a screenshot, guys, and try solving this question. All right, we're gonna go DP today. Now, at least. Um. Let me take a screenshot. Wonderful. It's gonna be fun, guys. It's gonna be fun. Supposedly. So let's see. You are given an integer, and also let me, our Pomodoro is working, and also let me start my own timer. All right, wonderful. We are good to go, I think, but we don't have, all right, hints are here. Wonderful. You are given an integer array nums of length n, all right, and 3 integers m, l, and r. Your task is to select, so a choice, at least one, and at most m, I mean one, at most m, non-overlapping subarrays. So you need to think about the meaning of subarrays. Subarrays means like it is not subsequence, and there should be some contiguity, right? It should be contiguous. Non-overlapping subarrays from now such that each selected subarray has a length between L and R inclusive, and total sum of all selected subarrays is maximized. The sum of. So we're gonna sum the item in our subarray. So it is a subarray problem, basically, and it is updated version of subarray. Maybe we can review the subarray, one of the subarray DP problem, but let's continue. Return the maximum total sum of sum you can achieve. I don't understand the meaning of non-overlapping. Non-overlapping meaning, let's say if you start like L and end at R inclusive, the next subarray will start at R plus 1, right? But instead of doing that, why don't we just, L and let's say X, like why don't we do this? Like select, one reason might be there can be some negative numbers, and instead of creating one subarray, you can multiple like a small subarrays and return the summation of those. Yeah, like to get rid of the negative ones, basically. This is why we may need to partition this subarray. Each selected subarray has a length. These are even not in indexes, but length. So we're gonna select subarrays, and their length will be between L and. So let's say 1 and 3. So we're gonna select subarrays like maybe like a 1 element or 3 elements subarrays. So the total length is like a 4. And our goal is to return maximum total sum. So there are different ways that we can create those subarrays, and among those we should return the maximum of them. All right. Explanation. One optimal strategy is to select the subarray for 1, yes, length of 2, and the subarray 2, like yes. Both subarrays have length, all right. Between, so all right. We're gonna create subarrays, and we need to find the maximum because there are some other subarrays. All right. So basically, guys, if we have like if we are gonna decide, I mean, if we are gonna create different subarrays, all right. Let's see our choices. Let's say L and R. So we can create. Actually, it would be great if we review the subarray problem. But let's see. We like we can create a subarray. So we need to create subarray. How can we create a subarray? We need a start and end index, right? Like maybe starting from 0 to 2, or maybe starting from 1 to 2. How we do that? How we're gonna do that? Maybe instead of deciding start and end index, maybe we can decide either start fresh or extend. Let's make this extend, because this decision tree is not going to help us. Extend or start fresh, since they should contiguous, since they should be contiguous. Let's say we have like a 2 5 7. When we are here, I mean, let's say we may have a previous, right? And we can extend it. I mean, we can edit, we can append the previous, and now our array can be like this, all right? Or we can literally start fresh, and when we start fresh, we can add that element into our subarray list right away. We don't need to wait until we reach the leaf nodes, all right? And also it's same for extending. If we append, we can literally count that like a temporary array as an answer, as a not answer but as a subarray. So now this is the decision tree. So we have two options, all right? Start fresh or extend. So we discover these options, these choices, and what are they gonna return to us? I mean, we have a subarray. We literally have a subarray here. We need to calculate its sum. Then what? uh but the thing is, like, I mean, for example, we have, let's say, x, y, z, a, b, c, all right? So the thing is, like, we can create like a this subarray, right? And then maybe like a this subarray, right? And then maybe that. The thing is, uh we need to, like, what I mean is that we need to find the valid subarray set, basically, right? I mean, we need to find all subarrays. I mean, not all the subarrays, but from left to right, create subarrays, all right? And then find their sums. Oh, no, we can just create all the subarrays, and we can create another for loop, iterate each of them, and find the minimum or maximum of them. But the thing is, for example, here we literally create. Let's go on example, right? Let's see it. I mean, let's see it. So let's say we have x, y, and z, and a, all right? Start fresh, like we are here. We start fresh, so this is our subarray, and we extend. This is our. Anyway, continue. Now we decide y. So if we start fresh, we get y. If we extend over x, we get x and y. So we have x again. Anyway, we can handle this later. So we have, but we should have different thing. If we extend, since we don't have anything before us, we have the same thing again. Let's say x, we have x, and then start fresh with y, we have y again. So there are some overlapping sub problems. Y and we x, oh, these are same, but let's continue one level further, but they are gonna be same. Like, how was it in cadence algorithm? Basic in cadence algorithm we extend. Oh, like we are at this index. If we use it and extend it, we should append it in the previous, and in the previous we don't have anything basically. This is strange. How about include or exclude? But include or exclude wouldn't give us the contiguity. We need to start fresh or extend basically. For the sake of time, let's make this empty, all right? I don't know why, but let's make it empty. Extend. Here we don't have anything, right? And we process this, and now we are here. When we start fresh, let's say we have y, and let's extend, we have y again. Like, I don't get the starting fresh idea. Anyway, we have y, we start fresh with z, so we have z here, and we append, we have now y and z. So what I mean is that, like, we create those subarrays basically, but what are they gonna return, right? They should return the problem definition. What do we have in our problem? Return the maximum total sum. Actually, maybe our recursive function cannot return this right away, but instead return something useful for us, and we can process it. Each selected subarray has and also we should apply this rule. Like, applying this rule will be easy after we figure out creating subarrays basically. Let me, guys, look at the subarrays problem solution for the sake of time. I don't want to spend 2 hours for this problem. Subarray lead code in Java. Let's see. Actually, we have solved this question before. Maybe not here, but where, I guess here. Let's open the subarray. We have cadence algorithm. How about sub? All subsets. I thought we have solved it, but apparently we didn't. Oh, Dragon Sohaib, welcome. I've always seen you solve problems, but I never understood what problem were or why you were solving them. Actually, I am trying to solve a dynamic programming question on LeetCode, like an algorithm question, and the reason why I try to solve it is make me a better engineer, basically, all right? Because we have a real world problem and we are translating into the code. There are some layers, all right? And for example, one of them is, you know, translating this and putting into code. Like this is one level, and another level and another layer is like understanding the data structures. Because when you want to design a system that is, you know, performative, that is fast, you need to use these algorithms and data structures efficiently to create a better system, like a fast, reliable systems, basically. I value these, and that's why I study. And these questions asked during the interviews, so that's another reason. um, but I really wanna be proficient understanding algorithms, basically. I can answer your question like this. Um, so let's see. Maximum subarray. Oh, I understand now. You are self. Yes, yes, I am. Exactly, exactly. Actually, this is cadence subarray problem, but I have studied this. Um, I thought there is a some problem like a, not permutations combinations in maybe big backtracking, but I remember a problem called maybe subarrays or subsets similar to that, but it was, I think, dynamic programming question, right? Or most probably it can be a backtracking problem too, but I wanna remember its name because it was short, like a 6 letters, 7 letters, something like that. Can you find it? So we know the subarray idea comes from the cadence algorithm. All right. Um, but when I try to draw the decision tree, it kind of fails, like starting fresh and extending. Because starting fresh means starting with X. Like these are literally the same. Maybe we can just forget about the first left branch and focus on this part only. How about that? Extend. So we, for example, here we have like an X, and here we have Y and XY. But these are subarrays that we get in different levels. What we need is complete, like a set of subarrays that um, you know, that creates our input. And include or exclude like a knapsack does not help here. We need to figure it out. Most probably it was subsets, guys. All right. Maximum. So so it generalized a known lead code classic maximum sum of 3. Mm. Now create an entry about this. All right. I tried drawing decision tree like starting fresh and extending, hoping for this will give us the subarrays we need, but it doesn't. And like I need to have a decision tree, so like use the, you know, current time, um, and add it into our website. All right, because I thought it's gonna give us and also like I figured that maybe our recursive function doesn't return the answer right away, like an answer for the problem itself, right? But instead maybe it returns something meaningful that we can again maybe use a for loop and iterate and process it. All right. uh, Maybe for example the problem asks return the maximum total sum you can achieve. Maybe our recursive method can return the sum of a subarray, one of the subarray, and we can run our recursive function like multiple times, right? Because I remember such you know, mini um, design pattern, mini pattern. But here, like I'm having kind of hard time, you know, designing the decision tree basically, because applying this inclusive rule, which is, you know, each selected subarray has a length between L and R. Like I assume after drawing decision tree, this should be easy. Like the another hard, like another pain point is that, like we can create, like let's say we create our subarrays, but the thing is, the summation or accumulative summation of the subarrays should mean the complete input. All right, we are not looking for individual subarrays. We need to calculate the sum of summation of one valid set, I mean, right? Let's see, guys. This is gonna be our first entry, I suppose, for this problem. So what I mean is that, for example, this is one valid combination. Actually, this is kind of combination question too, but we need to detect different subarrays. So, for example, this is a combination, right? And then maybe another combination is like a X and only A and B, right? So, like this is one combination. This is another, let's say, combination. And in our decision tree, like at each level, we already get a subarray, but we don't know where does it belong to, basically. All right. Or maybe should we, like, can we calculate? No, we can't. Actually, we can calculate the sum of it, right? I mean, let's say we have a subarray like a B, C. We can sum them, or let's say 1, 2, 3, right? We can sum it, and then all right, all right, all right. We don't know. We don't need. But my fear is, like, what if we like return the, you know, like a summation of a subarray? But what if here in this subtree we return another sub array that already contains, let's say, 1 and 2? How do we probe it this? Like, this is what I fear basically. This is my worry. Like we make sure that a subarray here does not appear on here. And also starting fresh and extending, like, it doesn't create, like it should create basically, because in cadence algorithm it literally does this. But there, I remember, guys, I remember we start our for loop from index 1. So we literally set our prev to, let's say, arrays first. So here, since we don't have, but we can make it, let's start with this one. So when we are, all right, let's try this, guys. Like, it's because in cadence algorithm we literally have previews, because here, since we don't have the decision tree, you know, troubles. Let's see, guys, let's see, we're gonna do this, guys. um so let's start here, like a, let's say in our root we have this, all right, and we start fresh. I mean, now we are processing this y, all right, the second item. So let's say we start fresh and we start with y. and here we append y, and so we have x and y. So now my fear is, like, we cannot have this one and this one at the same time in our, element of set. All right, because you can either have one of them. I mean, you can only have one of them. You can either have this one or this one, not at both of them at the same time. So let's examine the other part. So start fresh at Z means like a this subarray, and extending means that. All right. So, but if it's like starting from the like a lower level nodes, if we return only one of them, I mean, if we pick the one side, let's say, like we are not gonna pick this side or that side, but only one side. Is it still guaranteed that in the right subtree we're not gonna have something? Um, no, we can literally have, like, we have xy here. Let's say this picked y and z, right? We literally have y here, so we cannot use. Yes, we cannot use it, right? Um we cannot use it. We have to select at least one and at most non-overlapping, like non-over. Subarrays means contiguous non-empty sequence of elements within an element, within an array. Non-overlapping int. Or so, like, all right, continue a little bit more. So xy, and now we are processing z. We are starting fresh, and we are appending. So x, y, z. Let's have a2. We can start fresh with a, and we can append z and a. We can start fresh, and we can append a. We can start fresh, and we can append z and a. We can start fresh, and we can append. So what do we have at leaf? No, leaf level. Do we have something meaningful? For example, x, y, z, and a. All right. Americano is welcome. Sneaking in and see you. Hello. Sadly see you. Bye again. Really sorry. No worries. No worries. Thank you for dropping by. And Americano is redeemed rosemary oil. Like, I added um, a lot of different comments, like voice comments. I really, eager to, see you use them. I had some comments. Let me, like, I use motivate.
You were not chosen for the easy problems, you were chosen for this one.
We are chosen for this problem, guys. Come on. We are special. We are chosen for this problem. Thank you, Americano. Thank you. Um, so do we have something special with the leaf nodes? Like, I mean, let's look at the possible subarrays we may have by hand. I mean, we can have, like, actually there are many options. Like, oh yeah, yeah, there are many options. Like, we can only select X. We can only select. We can only select Y. Yeah, yeah. So we can only select Z. We can. you know, do this. All right, we can do that. We can do this, and also, guys, like these are anything, and also, so we can have like a x and then y. We can have, let's say, x and, you know, z. We can have like a x, oh my gosh, like a x and maybe a, right? We can have like a y and z. For example, we can have like a x and y. Actually, like, yeah, we like there are too many things, guys. Like um we are chosen for this question, guys. Come on. Um it's gonna be 1 hour soon. So like I'm trying to find which one we should calculate. I mean, maybe from root to leaf. No, like after selecting this one, I we cannot select this one. Like, how are we supposed to create some combinations? For example, like what will happen? Let's say we're gonna include this in our answer. We cannot go right. We should go left. And if we go left once, we can go right. No, actually we can go right, but either you should, you know, accept this one or this one, not both of them. I mean, by going down, while going down, don't add the subarray you see immediately to your answer. But what happens if we go right and right? We should again pick the greater one. Pick the greatest one. I don't understand, guys. We have y. So like after understanding this, and then we're gonna try adding this rule actually, like a ln var. So subarray length. So, but first I should be able to select subarrays. Maybe, guys, forget about decision tree. Since we know cadence algorithm, right? Just use it, right? And then try adding this rule there. But cadence algorithm was giving us um all the subarrays, and also it was giving us even maximum of it. Yes, it was giving us the maximum of it. Now our goal is after finding those subarrays, we're gonna select a few of them. I don't know how many of them, but we're gonna select a few of them. The question asks, return the maximum total sum you can achieve. All selected subarrays. So like we are gonna create subarrays and then select some of them that will give us the maximum. Like I don't want to lose 2 hours for this question, guys. I'm sorry. Like this is how far I could go. Let's read the hint. Let's see. Let dp be the maximum sum using Atmos C subarrays among the first I elements. We can do that, I think. This is, I guess we are not gonna use like a start fresh and extend analogy, like this approach. We're not gonna use this approach. Let's see. Um, so we should define a function be the maximum sum using atmos C subarrays. Atmos C subarrays. What is that, guys? Atmos C subarrays. All right. Let's say atmos 2 subarray. Oh, this is nice. This is nice. 3 subarrays. All right. Atmos 5 subarrays. Among the first I elements. Oh my gosh. So if these are our states, be the maximum sum using. So this is literally the answer to our question. So for example, imagine a decision tree, all right? And when our root returns, it literally returns the answer. So which other options we should explore here? We should explore with the maximum sum using atmos C. Maybe like a C minus one. I mean, C minus 1, C minus 2, C minus 3. How about that, guys? Among the first I elements. Actually, we should create the recursive relationship. Instead of focusing on these arguments, we should focus on the relationship between subproblems. All right. We don't know how many subproblems we have. Like we may have like a 1, 2, 3, or even n number of it. It doesn't matter. All like this is one situation, or we can have like a static, let's say 2 or 3 options in each level. We need to create the relationship, like a recursive relationship, be the maximum sum using atmos C subarrays. All right, we may have like a x, or let's say y and z. So we have 2 subarrays among the first I elements. So if we make this I equal to number of elements we have, then we're gonna get our answer. So all right, so this is literally telling us you should use this structure and you should now find your subproblems. We need to define our subproblems, guys. What are our subproblems? Our subproblems. So I'm using atmos C subarrays. So if we solve with 1, I mean C equal to 1, right? If we solve it C equal 2, and if you solve it C equal to 3, right? Using atmos C subarrays among the first I elements. Alright, we're gonna solve it, guys. We're gonna solve it. Don't worry about it. Don't worry about it. We're gonna solve it. Be the maximum sum using atmos C subarrays. Atmos C subarrays. So in the question, what is the upper limit for subarray? I mean, number of subarrays. Both subarrays have length between L and R, but it doesn't talk about the number of subarrays. Or does it? What is M? Oh, alright, we have M. Alright, we should define our state. Alright. We should. So if we solve the state with like a M equal to 1, then it may help us. Apparently it will help us, because it exists in the definition of our problem, our recursive function. We're gonna do it, guys. We're gonna do it. So we have m, and then what? What else we have in our problem definition? Like we should have the numbers as well. But what else we have? We have, come on, come on, come on, come on, come on. Among the first I items, I elements, it has like, it sounds like an index because, for example, in some DP problems, we literally use this index to define our sub problems and problems. Here, all right. Now I need to see, guys, the relationship between, let's say, guys, we need to find the relationship between literally I minus one, actually, like function ci, or I like using index first and then and other parameters. So we literally need to create, for example, if we solve this problem, if we solve this sub problem with Atmos subarrays, what other sub problems we need to solve? Maybe one sub problem might be this, and the the second one might be like this one, Atmos series, and then and then we should, okay, these are our sub problems, and then the current, I don't know. Let's look at the another hint. A subarray ending at I and starting at J, ending at I, contributes prefix where do we need to do something about prefix array? Oh, do we? A subarray ending at I. So in our problem definition, we have this I, or we don't. No. It is something else. A subarray ending at I and starting at J contributes prefix. It literally prefix minus prefix J. This one gives the subarray we want. This gives us the subarray we want. I mean, prefix I minus prefix J gives us the subarray summation, actually. Yeah. So, all right. So the other clue is, guys, we need to use prefix. Oh my gosh, it is ugly. Let's see. Let's copy here. This is our second int. All right. All right. A subarray ending at I and starting at J. I need to see it. A, B, I, J. Prefix I. Prefix I means this, and prefix J this, and the subarray we get here subarray ending at I and starting at J. The J is gonna be here. It must be J and I. Yes. This is the subarray we need, we want. Actually, I have solved a question in prefix, but alright. So we need to use prefix apparently, alright, because prefix gives us the, you know, with the given start and end index, it gives you the summation in O1 basic. Like in one pass, you calculate this prefix array, all right, and then when you need to, you know, let's say between like index 3 and 6, give me the sum. It can give you the sum in O1 basically. This is why we use. All right. Maximum sum of using at most sum array. Let's say 5 subarrays. And here among the first I elements. So let's call it rest. And if we have this x, y, and z, right? So we literally solve this part of question. First I elements, let's say. And 5 number of subarrays. Alright. Among the first I elements. So imagine we have A, B, J. These ugly now characters. This is alright. So imagine we have solved our problem here, right? We know, like we have the answer for C and J, right? Was it I? No, I. Um, Meaning that first I characters, we solved our problem with the, you know, 5 number of at subarrays at most. We know the answer, and um, when we are processing the current element, I mean this for example, actually this is definition of this one, let's say, all right, this is the definition of this one. Actually no, I like to think about post order. So let's make this idiom the answer for this sub problem. What should we do to calculate the answer using this character? So apparently we should have like a maybe same C, right? I don't see the effect of C right now in the recursion, but let's make the C stay still. But now I should increase a parent. Like when we are processing this, now the definition of our this problem is this one. And if you know the answer of this sub problem, I don't see how we change C. And also I don't see what other stuff we need to create this recurrence relationship. We know that we need to use prefix. So basically, to calculate any subarray summation, you can give me just 2 index and I can literally give you the sum. So, but again, you still need to create those subarrays. But which subarrays? Let's see the third hint, guys. Rewrite the transition. Oh, like this is good, guys. Like if I know this and maintain this maximum with a DQ, like we literally have the recurrence relationship. Like then it should be easy. Like this hint is, um so we define our, I mean, C and I, yes. And the recurrence relationship is we get the prefix I, meaning the first I character's summation, yes, and maximum of function C minus 1, but why? I mean, um, we decrease the number of subarrays by 1, and J. What is this J? We have max here, but what is the second parameter? Maintain this maximum with a Q. The second parameter should be the Q, I think. But what is the Q? Anyway, max of uh, minus prefix J. Let me rewrite it, guys. So the current problem can be get using this recurrence relationship. Max of func, oh my gosh, C minus 1 J, oh my gosh, guys, let me remove all of them and only write this. We know this. Let me write on the right side prefix. So the summation of all the numbers, right? And then maximum of these are two options, maybe, right? Yes, yes. Function C minus 1 J. We don't know anything about J. What is J? Minus prefixes. So J is quite important that we use we subtract all the summation. Oh my, this is complicated. Yes, and then this is first part, and then I don't understand the parameter here. Um, Rewrite the transition as and maintain this maximum with a Q. What is the second? Where is the second parameter of this max, guys? And maintain this maximum with a DQ. What is DQ, man? All right. It is quite fun. um, like we have max, but there is no second parameter. All right. If we try to draw the decision tree now, let's say, like first I with the atmos C number of subarrays. Um, Two things like there are like we things we discover is like calling this one, right? with the one less let's say atmos 4 number, and the j. What is this j, and how do we determine this j? Let's look at the question again. So first j, for the first j characters, and atmos c minus 1 amount of subarrays, we find, we make a call. So we basically make this call, and then we subtract prefix j. All right. And then in the root we have something more. We get the maximum of like either this one, but what is the other one? Maybe we need to type this, maybe, I don't know. What is the other option? C and j minus 1. And then we should make another call and then get its answer, and get the maximum of them, and then add prefix I on top of them, and then return that as an answer. Like, this is the thing. But all right. So instead of wasting time, all right. Actually, what was the second hint again, guys? Let me copy. Subarray ending at I and starting at j contributes. Yeah, we know it. We know that this is the feature of prefix, basically. This. What was about the first? Yeah, we know it. Alright, so let's see. Now let me, guys. Alright. Now the thing we have done is like a trying, like a start fresh and extending, but this doesn't give us the subarrays we want. Like, it gives, but there is no possible way for us to calculate all the possible options for us. All right, there are some overlapping cases, and also there is no way to know to eliminate the for example, we have a character, we use it, and we can use it in another subarray too, and in our decision tree there is no structure for providing that. So in the hint, in hint 3, I guess this is the recurrence relationship between like what I know with the dynamic program questions is that we need to define our problem using sub problems. Like, it was amazing hard to come up with this kind of thing, but let's assume we know, like, we created this recursive relationship, and after that now I'm trying to create the recursion tree, decision tree, or recursion tree, and then I'm gonna apply top down solution, like top down unoptimized top down solution, and then I'm gonna use memoization, and then try to solve it bottom up. But here the thing I don't understand is that it's like in hint 3 it said that like a rewrite the transition as this one, but in the max, like we don't have the second parameter. Like, is it wrong, or am I supposed to know something else? And also, what is the Q? I mean, it also said maintain this maximum with the Q. Um, yes, like these are the parts that I don't understand. Create an entry about this pain point. Um, like I know the fundamental of prefix, but I don't understand how we created this recursive relationship. Maybe later I can focus on and try understanding it, but now, for the sake of time, could you please explain the recursive relationship? And I guess in the hint we are not, I mean, it is not expected to, see, I mean, get the answer, get the recursive relationship, because it's quite important. So why in the hint we see recursive relationship, and maybe we don't have it, but we have part of it. What do you say about it? Like, this is hard, guys. Like, I wouldn't be able to create that recursive relationship. Like, I mean, maybe after, I don't know, man, I don't know. Like, for this problem I should be, efficient. I mean, I should have solved, I mean, I should know some prefix problems, like, all right, and I should be, maybe after then I could be able to, use the prefix knowledge and then using the recursion knowledge and put them together. But here I couldn't manage to create a recursive relationship. Yeah, so maybe one day or maybe multiple days we can focus on the prefix. I only solved one question in prefix and didn't review it for some time. Maybe we can open here, like, um, not prev, but what was it, guys? Prefix. Like, the only question that I have solved is this one. Um, we have two indices, like a start and end, and the prefix sum is equal to summation of first j element minus I minus 1. I should solve it again. Anyway. Oh my gosh. So you are explicitly asking me to explain the recursion round. Exciting tutor mode for this. And your meta instinct is dead right. So let me start here. First, your meta question, the important one. Deriving the recurrence is the hard, central skill of DP, and hint 3 skips it. It hands you the already optimized transition, and that's exactly why it feels unmotivated and confusing. You are looking at the destination without the derivation. I like the term derivation. That makes it obvious. So we'll rebuild it in the right order. Actually, if it is in the hints, then maybe we can continue. Look at the beauty, guys. The preface trick. Alright, we're gonna read it, and the fill picture version 1 and version 2 small console. You can do the plain double loop, no DQ needed. The DQ is mandatory, or it is alright. Monotoic DQ. The fill picture, alright. You do have part of it. You had the state idea. How many subarrays left? And the return a piece, combine outside instinct. What you were missing is the last subarray. Prefix I minus prefix J. which makes J the thing you maximize over. I guess we can read it, guys. We can read it. So you are explicitly asking me to explain in the recurrent. Yeah. So yes, driving recurrence. The state, the best total sum when you have placed the C number of subarrays using the first I elements. Like even doing this kind of hard. Anyway, where the Cth subarray ends exactly at I. Uh, all right. 2 dimensions. Your 2 pain points solved. C answers. It's a set of M, not individuals. Yes. You count them, and I is a usual index. This is your 4-slot skeleton. 4-slot skeleton. What does it mean? Choices carry down. C and I combine. I don't understand. Choices carry down. Choices are these. Combine is max. So yeah, using the return value, we should combine and get the maximum of them. The unoptimized recurrence. Derive this first. The Cth subarray covers some range. Look at this, guys. Like, this is the key. This is the core. The Cth subarray. Oh my god. For a second, I thought it is 5 p.m. and I got scared, but alright. In India, it is 5. In Germany, Switzerland, Brazil. Oh, it is still early there. Let's go with Brazil. The Cth subarray covers some range. But why, like, why do we use like J and I for the C? Because C means at most C number of subarrays we're gonna have. Actually, it is coming from the definition of the problem, guys. Because in the definition of problem, each selected subarray. No, it is length. It is the length. All right, we're gonna see, guys. Its sum via prefix sums is prefix I minus prefix J. The Cth subarray. No. I mean, I thought. So we have the index, basic index of a subarray, like a Cth subarray. So let's say we have at most 5 subarrays, and the fourth, like since it is 0 indexed, fourth subarray covers some range. We are looking at the last subarray. All right, its sum via prefix sums. All right, look at the J, guys. J is not inclusive; it is exclusive. All right. I really like this idea because. All right. Let me draw some subarrays. All right. So imagine we have, let's say 1, 2, 3, 4, and 5. All right. Imagine we have 3 subarrays. All right. 3 subarrays. One can be 1, 2, right? And the other one can be 5. So now we are thinking about the Cth subarray, which is 5. So its index is ij, but what is, I mean, this I, like, we can use I here, right? And let's call it A. So that I can be the index of 2, but here we should exclude it. All right. I mean, since we have some other subarrays before us. But there can be, I mean, there can be a way where we like use this inclusive. All right. We have prefix sum. Before it you had c minus 1 subarrays packed into the first j elements. Like, this is crazy, guys. This is crazy. Like, this clears some fog. All right. Oh, so that's why, guys. That's why we use this to define. I mean, we use this to define our problem. I mean, these are this is one of our sub problems, I think. And actually, only sub problem we need to represent our problem, current problem. That's the honest low recurrence. So let me. Could you please create a entry in our website, because I really loved the representation of a sub problem. All right, here, because we defined the cth subarray. All right, covers some range from j, I mean exclusive j and inclusive I, and its sum is prefix I minus prefix j, like the summation of the last subarray. All right, in our answer is this, and before it we have c minus 1 number of arrays and packed into the first j elements. I love the way we put the question into definition. Like, since we have two parameters, like, it seemed a little bit hard, but like when we think about the last subarray, but now what should trigger us thinking about the last subarray? Because we may have multiple subarrays, like we don't know how many we have, and that's why we use seed, I think, right? Because let's say we may have, let's say, one, maybe like a two, and then three, right? Like, these are the previous ones, and now this is, for example, the current one, and we literally defined our previous one using like I and J indices. And also, while defining, we used C, I mean total number of subarrays in the answer. Since this is the one of them, the remaining number of subarrays will be this. This is good, guys. Like, this is good about the transition, language transition. I mean, this is good. This is good. But why do we think about number of subarrays we have? Like, I literally tried finding every subarrays. All right, here I literally tried drawing, like, having all the subarrays, but instead we didn't try finding them. Instead, we said, let's say, assume we have a last subarray, or like we didn't calculate that one, or we didn't think about that one, all right? But we think about a last subarray, and actually we don't care about the elements, all right? We call it like a I and J, right? Actually, I plus one and J, and we defined this subarray. Yeah, so seed subarray. Actually, here we don't define the answer. We define the last subarray, basically. right? So actually no, we don't define, I mean, we don't specifically define the last subarray, but we define the other thing left from, like if we extract the last subarray, we defined what we have, and it is a sub problem, it says. I think we need to understand this, like why using a subarray, all right, we extract it into a solution, any solution, and we define the thing we have after we extract the last subarray. This is good, this is good. The new seed, all right. So that's the honest slow recurrence. You should be able to write this yourself. All right. So I need you to create another node. So I realized that, like, for example, at first, like when we start solving this problem, I tried reaching each subarrays. All right. I tried, we tried creating each subarray so that maybe we can find, and also which terminology should we use for like a answer. I mean, by answer I mean, let's say we may have like a one subarray or multiple subarrays in our answer that we maximize. All right, like is it like what is it called? Because here like at first we tried to find all the subarrays, but we also needed to like find answers, like multiple answers. All right. Because subarray alone does not mean anything. It needs some other subarrays to uh, create an answer, basically. All right. We basically need some combination of those subarrays, and also um, and also we should be careful about which item we include. So basically, a subarray cannot contain the other elements. All right. If we are going from left to right, if we include an item, then we cannot include that item in the next subarray. All right. So my goal is now to understand how we design design this sub problem, basically. And also, while explaining things to you, I realized that like subarray, like defining the subarray is quite important. I mean, we're gonna use subarray to um, to create our definition of sub problem. Now, comes the second part. um, and also, like as I said, we focused on creating each subarrays, but it wasn't possible because even we need to care about the combination of those subarrays. And now in the solution, I mean in the hint and in the, like as you explained, like we didn't care about, all right, we didn't care about what other subarrays we have in our solution, in our current solution, let me say. um we call them as uh we call them as from 0 to I, right? Or in our case I minus 1. All right, this is actually, it is not the subarray, but the items, the available items from 0 to I minus 1 inclusive. um these were your options, right? um and at most, hmm, actually these are the items, like available items for the subarrays. I mean, I'm trying to understand how we come up with this subproblem definition of, you know, c minus 1. Actually, now I can see it because we focused on the last subarray. Basically, we focused on its indices, all right, and we thought about the state where we extract it, all right. When we extract it from our solution, the you know the thing we have is, one less number of uh, Atmos subarrays, and the n index now is I or I minus 1. It doesn't matter, but one less from our start index of the current subarray. So we literally define uh, our subproblem using this. But now the question is, like, how would you, how am I supposed to know that I should use the last subarray and extract it and then see and evaluate what we have left? Like, because the core part is using that last subarray. Like, it is quite interesting. It is quite interesting. It's been 5 hours. Like, what did we say? So after this dynamic program, we're gonna continue with more greedy problems. All right, let's see. So, like, this is the sub problem, literally definition of sub problem. Like, after extracting the last subarray, but this is not only enough to define our current problem. We need another data structure, like a DDQ. I don't know what that is. Like a max over valid j of. Like, we're gonna focus on that, but so these earlier C1 subarrays. So, and here is, this is the current. Like, this is the current subarray's value. If you add it into on top of the previous subarray, you get the summation, basically, right? Summation of, not summation of, but maximum. I mean, you literally answer your question, like, and your question is this, guys. Where is our question? Like, after making this move, you literally get maximum total sum with where is C here, guys? Where is C? We don't have C in the question. We have it. It is M. Where is the definition of M here? Oh my gosh, let's open the question. At least 1 and at most M. Alright, we have it here. M number of subarrays. M number of, like, the way we use this like the way we translate this into our code is nice, guys. We call this a C, and we define our problem based on that. Like, it is quite important, and we use it. And then for the sub problem, we extract this last subarray, and then define the sub problem. And if we add the current subarray into the, then we get current problem. So this is actually, it is easy. It is kind of easy. Yes, yes. Like you may say, get out of here. It is not easy, but um, I mean, there's prev basically, and there's current element, right? Current value. If you add this, you get the like this is the generic idea for every DP problem. But the understanding why we use the last subarray and how we use it is kind of hard. I get it, but the generic idea is same. We have a subproblem, and actually, guys, there are some DP problems where like where it is not like this. For example, oh my gosh, guys. So for example, in a climbing stage problem, like I love giving this as an example, right? In this problem, we don't get a value or something like that, all right? We define our like a current function using only these. I thought we have something like that. In this question, we literally only use one subproblem, not two, and like we use only one subproblem, all right, and a value basically, all right. Like this is our last subarray. Arrays summation, and this is like without that interval, your answer without the last subarray basically. But you extract subarray both from the indices. Yeah, like I mean you extract it from indices too. And also about the number of subarrays, you also decrease it both from C and also summation and index. C and index. Oh my gosh. All right. Define the problem in terms of itself. Yes. Assault small. Two takeaways to lock in. Answering your two questions directly. Terminology. The thing you maximize is a selection or configuration. A feasible solution. Selection. The whole combination of M subarrays. Each subarray is a part. And the number is the objective. A part alone is meaningless. The combination is the answer. How do I know to peel the last one? That's the single most reusable DP derivation move. Oh my gosh, like I like this term. DP derivation move. Condition on the last decision. Condition on the last decision. Hmm. Hmm. Last decision. Oh, I really, I really, I really like this. Condition on the last decision. So maybe we should focus on maybe we should have focused on the last decision. So the last decision is selecting a subarray. Hmm, that's good. That's good. We don't have a dynamic programming, right? So this is our first DP problem. Condition on the last decision. I really like this term. Let me also put this here. Let me paste it over here. Like focusing on the last decision we make. Like actually this is generic. We can apply this on maybe like every DP problem. The generic approach we can use for every DP problem. All right. Maybe even assign some colors. Every solution has at least has a last piece. Fix it, remove it. What remains is the same problem, one size smaller. You'll use the exact same move on. Oh, okay, knapsack, coin change, distance. Like these are the problems that I have solved. Amazing, guys, amazing. I really like this one. So when a recurrence won't come, what is the last choice and what is left after I remove it? That question is the recurrence every time. All right, all right. So you are at here with 12 node trail, keep coding or wrap here. I'm not. Did you create that program? Which program? I need some motivation, guys. Motivate. The one you were just. Oh, yes, yes, this one. Yes.
Spin up, lock in, and let your very best work fly.
Let the best your work fly. Not to store all your info. Oh, I mean, you are talking about this one. You are talking about this one, right? Yeah, like this is no, not the other one. So the other one is not taking application. This is not taken application. I use especially for lead code because I take lots of screenshots, lots of notes. It is on my GitHub too. Like you can use it there. Um, yeah. So did we make you yeah, you are trusted. You can send um voice commands. All right, all right. So we can continue. We have 3 minutes left. But we didn't understand the DQ part yet. We don't know anything about it. Um, so now, for the sake of time, I wanna wrap up here, and then I wanna continue with another greedy problem, but save it there. And also maybe maybe you can create one last entry, and there maybe you can add that our next focus should be about the DQ part of this problem, because we need another structure to find the answer, right? So for the sake of time, guys, we can continue with our grid min swams minus. So this question was like actually the thing I really like about this question is the counting. What do we have? Counting gradient. Yes, constructive gradient and counting. So it is counting gradient. So this question taught me these two types. Like it exposed these types for me, subtypes. Counting grid. Let me change this to alright. So now our next grid is this. Let's see what we have here. It is another part, but let's see, guys. Stamping sequence. Should we use some sort of stack or something? You are given two strings. Initially, there is a string S of length will O. In one turn, you can place stamp over S and replace every letter in the S with the corresponding letter from stamp. For example, if a stamp is this and target is ABCBA, then initially in one turn you can place stamp at index 0. We're gonna focus. We're gonna read it, guys. We're gonna read it. Paste it, and also paste it over here, and also let's update the current topic. Topic stamping the CQNJ grid. All right. Now we are gonna focus on this problem. Create the first timestamp for YouTube. You know. So all right. So we're gonna solve this later. Maybe we can create a new group. Forget about here. Alright, we're gonna solve this too later. And this is our current problem. Stamp and target, alright. And we don't have any hint. Alright, we're gonna handle this, guys. Alright. Reset, alright. Now tutor mode confidence audit. Which part stamping? Alright. You are giving two strings, stamp and target. Initially, there is a string S of length, target length, all right, with all. So we have like a lot of questions, and we are gonna convert them into something, right? Let me also. All right. You are giving two. All right. In one turn, you can place stamp over S like a this. For example, we have like a question mark, question mark, question mark, and then let's say we place, a stamp basically, right? For example, this, like this. In one turn, you can place stamp over S and replace every letter in the S with the corresponding letter. I mean, what does it mean? I mean, does it mean like if I stamp X and do I place here like X? In one turn, you can place stamp over S and replace every letter in the S with the corresponding letter. That is interesting. For example, if stamp is ABC, a target is this, then S is this initially. In one turn, you can place stamp at index 0 of S and obtain, we literally stamp that. And then in the next term, we can, at index 1, where exactly are we? At index 1. Like this is index 1. I don't understand the index. Place them at index 1 of S. But we updated the array, we changed the array. Our array was this, like A, B, C, question mark, and 0, 1, 2, 3, 4. And now it says that stamp ABC into our index 1, so it should become this one, but somehow we also produced question mark here. So place stamp at index 0, index 2. So let's see what happens after uh, stamping ABC to at index 2. We get ABC, and then we're gonna produce somehow magically to, let me use another color, like a question mark. Yes. Note that stamp must be fully contained in the boundaries. All right, this is good. In order to stamp, you cannot place stamp at index 3 of S. So this is some sort of case. So yes, we can do this. We can, for example, if the length is 3, then the last index we can set is 2, basically. Here 2. And we can get this from subtracting the length of the target from length of the target minus our length, and this give us 2, and this is the index that we can place at most. This is the formulation. We want to convert S to target using at most 10 times target length turns. Oh my gosh, this is something crazy, guys. The number of times that we're gonna run, like imagine a while loop, and that while loop is gonna run this time. At most target length. If target length is 5, then in 50 turns. But like, what is the meaning of stamping? How does it affect our tries? All right, and what makes stamping again and again? How are we supposed to get the target? I get it. For we have, the target is kind of different, like ABC and then BA. So for this part we can paste here and get ABC, but for for this part, like a B and A, like making them B and E kind of hard, because for this part we should stamp at this like ABC, and also we should first insert like ABC here, right, so that we get B, and then insert here ABC, and then insert ABC here, like in 3 ABC insertion, I suppose, but I didn't think about the question marks. Let's say A, B, C, B, A. For example, we first should, insert here, like here in this index, A, B, C, all right, and then insert here like A, B, C, and then insert here A, B, C, and now we get A, B, C. This is the last one of them, and this is the here last of them, and here the last of them is B. In 3 moves. Actually, now when we look at this kind of this, I mean, from like looking from like a bottom to up, the first character we see is the thing we have written here, but making these choices is the thing, right? And let's see. Return an array of the index of the leftmost letter being stamped at each return. If we cannot obtain target from S within this target, return an empty array. What are we doing, guys? And since I'm looking at the time of Brazil, all right, so now local time is 3 p.m. All right. I don't know. Return an array, like even the return type is kinda interesting. Return an array of the index of the leftmost letter being stamped at each return. Return an array of index. What do you say, guys? Maybe we should just motivate ourselves or not. Run, push.
No more excuses. The function compiles when you decide it does.
Oh, when I decide, it will compile. So let's try creating something compilable. That's gonna compile. So return an array of the index of the leftmost letter being stamped. So basically, it says, I mean, since we are ABC, it asks this. Of course, this is the thing it needs to ask. So here it is like a 0, 1, 2, 3, 4. It is 2. It is 4, and it is, I mean, here 0. So basically, we need to return like a 2, 4, 0. We should be all right. Like forget about this for a second, and now the thing we should focus on, how do we decide where to stamp, all right? And is there a better option? Is there an optimal option? Is there an optimal index to pick? And how do we calculate that index? And our goal is like turning actually turning the S into target. So we have also this string. I'm kind of clueless, guys. Like, should I try drawing decision tree? Like, we have like a 5, like a, the S is length of 5, right? We have 5 in the indexes, and we can stamp here, stamp there, 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 and there. Like, these are our options. These are our options. But one of them should have a dominance over others. All right. But which of them and why? Let's say the length. Maybe it has something to do with the length. Like, our length is 3, and the target length is 5, and our length of, I mean, our S's length is also 5. And also, like, while it is about like a length, it also about it's also about, let's say, the position of characters apparently, right? And what do we get? What do we get with each stamp? Actually, we make some part of our string s, one step closer to the target. We are getting closer. And also, like, from the last question we have solved on DP, like, what did we do there? We thought about the last step, all right? Forget about these, all right? And let's try defining the last step, all right? For example, we had actually as we stamp, we also should do this question mark. No, question marks, the place where we didn't insert anything, right? Actually, the part I don't understand is why are we getting, why are we losing this first A? I mean, A index at, that is index 0. Why are we losing? Place them at index 0 to obtain this one. Oh, all right. I, for a second I thought that we stamp this one and then this one, and then like there's no sequence among these. So we literally, all right. So after inserting, this is what we get, and then after inserting that one, we get, you know, question mark A B A, basically, right here. And after inserting that one, we're gonna get ABC. So the last step, I mean, in the last step, we have that one, and yeah, we have that one. All right. So all right, let's try thinking about the last step. In the last step, we literally insert at index 0. All right, A B C. How do we define our problem? We define our problem with the remaining, like a remaining unmatched parts. For example, our like, we should also think about our target. Our target was like A B C and B A, right? So we should define our subproblem using like a, this part is already done, right? I mean, they are matching. They like S and the current thing we have, like a current S we have, we don't need to worry about this part anymore at this in this at this moment. We don't need to worry about that, right? uh, and we need to fix this part. If the part that we are gonna fix has the same length as the length of our what is it called, stamp, um, then we don't need to worry about anything, because we just um, insert at the index of leftmost size. Are we gonna do leftmost side every time or rightmost time? like our options were, like a leftmost, like a index 0, 1, 2, 3, 4. And for example, at the like the last step, we should insert at index 0. But what if we had, let's say, x, y, z, um, d, right? And then ba is, I mean, is our string. Then where would we insert it? Leftmost, rightmost, in the middle. For example, what we get inserting from here, like a leftmost side, like index 0. We get this, and then uh, actually, for example, here we can have like a B, or C. Like this changes the question. And if we have A here, we should insert our stamp ABC here, and now this part also breaks. We So our choices can, um I mean, can and will affect current solution in a bad way. I don't know. And we don't have any hint. So reverse. Oh my gosh, I don't know, guys. Like, I really wonder when it's gonna be like, this belongs to that gritty sub problem. Hint, have you, all right, we have a hint. Have you tried going where? I didn't, but why? I mean, why would I do that? What should trigger me to do that? I mean, have you tried? I haven't. So maybe for this kind of problems, like we should try multiple things, like a reversing, multiplying, dividing, dynamic programming, using sliding window, like a two pointers, like a DP approach, like a maybe I should just draw like a tree or something. Like there are many questions. I mean, there are many possibilities. One or a few of them should, uh direct me, should trigger me. Um, let's try reversing. Like this is the part I don't understand. Let us try. Let us try and see what we have. I guess you are. Have you tried going backwards? So we have A B C B A. So instead, actually, I haven't thought about like which way we are going. I mean, if we are gonna handle this in ON, and if I need to pick a direction, like a going from left and right, but actually I haven't thought about the direction because, I mean, after each edition our S also changes. So maybe instead of like a going in some direction, like it should be kind of dynamic or something, right? Have you tried going backwards, like going backwards on S, do you mean, uh, or on target, or both, basically, since we compare them? I see three things that I can go backward here. um, stamp starting from the end of the string. Stamp starting from the end of the. So let's say we have this S string, and if we start stamping from end, all right. So what do we get? Let's try. We get A here, and then let's stamp ABC here. But this won't get us anywhere. Stamp starting from the end of, and let's see what we have. I mean, from right to left, one by one. Should I stamp in like in this way, or do you mean stamping in correct positions? Apparently, but which position is this? Which positions are those? I mean, what we get is now, let's say A, B, C, and C. We are getting A, B, C, C. Hmm. So, hmm. We get C here. Like now I feel like now I see some stuff. Like because to make this part C, for example, we inserted for so after some amount of insert, but actually to make this C, you can like insert like this, or you can insert at here like at this index and ABC, and you got C here. I guess I need to try different like inserting and observe. Like I need to observe, but I see lots of things to try. Which one is correct? Like I can insert like this way, or maybe from left to right. Um, what do we get? Well, like where should I insert in each iteration? There must be a logic. Mm. Stamp ABC. Target. So we have S. Question mark, question mark, question mark, question mark, question mark. We need to convert this into target. All right. So each character of this string should same as this one. We can make this one by inserting literally this stamp, right? And when we insert something at index, we literally like we are actually while making that um, character as A. I mean, yes, because if we insert there, we make that character same, and we also make the remaining same. All right, like there is a cost of doing that. All right. Let's say we have A, B, B. What do we do for that? For example, we can insert A, B, C here, and then to make this B, um, to make this B C. What do we do? How so to make this B? I can insert A, B, C here. I mean, at index 1, I can insert A, B, C and make this. So there are for making an index same as the stamps So this is easy, like making the character easy. But for example, making B is kind of hard because you need to insert one left and then you get B. But then you break. I mean, if you insert ABC here, what you have is like A, B. So like now you have this one. And then now what? Like our target. Like I need to pick an example and study on that. I need to make some observations literally. So ABC, all right, ABC, and ABB. All right. So let's say we have actually we have S. I mean question mark, question mark, question mark, and a target ABB and a stamp ABC. All right, we need to observe. We like I literally need to see it. So nothing as then. So we have ABC, and our goal, like our target, is this. So let's try making it. So we don't we insert here. We start from 0. We don't go from top down. We are going bottom up, right? Um, like let's insert here. I don't know where, but let's insert here. All right. Now we have ABC. All right. Now we have ABC. Target is ABB. So, like, I should insert AB, like ABC here at index 1, so that this becomes 1, the last character. So, this is insert, and the output is A, A, B. Now this is output after insert. After insert. This is insert. All right. After insert, we have this. Now it is ABB. So to like, I wonder in which order I should try turning them. I mean, should I start from right? Have you tried going backwards? Going from right to left on target? Or I mean on S. So there are like there is S that I can insert and then build something, or there is a target. Actually, we're not gonna add target, and there are some greedy problems where like we shouldn't count this, but instead we should find a trick or another stuff. So mm, all right. So I have thought about it a little bit, and the pain points are like we have string S, like in which position should I start inserting ABC, right? And inserting ABC sometimes, yeah, most of the time, breaks the a good solution that we created in the previous step. So this is something. Um, and like I feel like there are some grid problems where like instead of trying this, we should come up with some sort of you know another variable. For example, instead of choosing like indices, we instead uh, you know find another parameter, and using that parameter we decide which one to pick. But I guess in this problem, like I feel like I should try inserting and see how the characters are changing, basically, right? and based on that, maybe I can come up with an idea, right? So create those pain points. Like I guess I need to try these and see how the characters are changing. Basically, like I need to observe. I literally need to observe. So maybe we can also generate. All right, so a PNG file basically, right? Uh, and also maybe mm, stamped sequence. Yeah. So here, for example, let's say we have a. I mean, let's say the target is A B C B A, and stamp is A B C. All right. I mean, we literally need to see how they change. So we have also like a 5 question marks, right? We can insert here and then question mark, and like we should also see the target A B C B A target. So like this is target. So for the parts that they match, like we don't need to do that, but for example, first question mark, I don't know, man. Like, should I think about this one and turning them into B? If that's so, let's insert, all right, A B C there, and it becomes this one, right? And yeah, it literally this. So this is still not same as target. We need to make the C as A, then we can insert ABC at the end. A B A B A. All right. Mm, and now we have C. I mean here. All right. We have C. Now we need to make this. I don't know, guys. Forget about it. Your observe don't guess plan is exactly right, and pain point is the clue, not the obstacle. You said a new step overrides and breaks earlier work. Sit with that one sentence. If stamping is destructive going forward, what does that suggest about the direction is easier to reason in? I guess it has something to do with the hint that Aymanat gave us, guys. So when you observe, take uh, take target, and instead of building it up, try the reverse. Find a window that already echoes the stamp, and watch what helps you when you blank it out. Observe that. No more from me. Go watch the character change. Um, so when you observe, take target ABC, and instead of building it up, try the reverse. Find a window that already echoes the stamp, and watch what helps you when you blank it out. So, like it says, this is our target, right? So we should create the reverse C B A B A, right? C B A B A. Should I insert the reverse again, like a CBA? What do you mean by that? CBA, CBA. I CBA here. CBA. I can insert C here, and it can become B. I don't know. Create a PNG or multiple PNG files to show the reversing and finding something meaningful. Aymanat said, I think it's trying to say if you have target AB, ABC, and stamp ABC, if you stamp at index 2, 0, 0, 1, 2, yeah, you blank the correct one, so it becomes AB. Yeah. So instead of stamping the characters ABC, you say, or since we are going backward, if you stamp at index 2, you blank the correct one. You blank the correct one. So now we need to, I mean, does it mean now we need to care about turning this, like creating this AB? Instead of stamping the question marks now, we are stamping the target and work in reverse order. All right. Like stamping the target was my first move without logic, but uh, we are stamping the target and work in reverse order. Like I didn't catch the reverse order, but let's continue. So um, so then when you find where to stamp AB, that's at index 0, you now have index 0 to 2 as your stamps, and that is a valid solution. I will understand, I suppose, what you are saying, Aymanat. I need to think about it. Like, grid stays ahead. This is not us. Let's see how, what will it say. So, like, we stamp it, all right. But what is the reverse moment exactly? I mean, it's like we can insert a target, yes, and now we have like a AB left. To create AB, we can insert like ABC at index 0, but then we break this A. Let's see. We'll see, Ayman. We'll see. Like we are stamping on the target. Should I draw it? That will be wonderful. That will be wonderful. Uh, yeah, you can join here. It is also generated this image. Let's see what it says. Start and done. So read it backwards, unstamp until all. Read it backwards. So ABC. So question mark is wildcard, matches anything. ABC. Alright. Like it literally, we are literally adding question marks. Like from index 2 to 4, it matches the stamp. Yeah, so unstamp 2, 0, 1, 2. From 0 to 1, A, AB question mark. Question mark covers C. No, I don't understand it. Unstamp order. Like, can you also use this that animation creation thing and create an animation for us? I think I need to see the movement. We have another image. Let's see. What's, what the observation reveals. Match a window when for every position. If the character is same as the stamp character or character is question mark. And at least one real character, not all question mark. Question mark is a wild card. A blank spot can stand for any stamp letter. That's what lets the next unstep overlap the last. Unstamp unstamp. So we add question marks. Loop until all question mark or stuck. Scanning for any matchable window. If a full pass changes nothing. Oh my gosh, like let's see the animation, man. Hold on, the blender is I mean the animation using three. I mean you know which animation we are using, um, which open source library we are using. So use that one. I mean except Blender, we use some another one. You know. Press enter. I see my shadow. Where does oh from here? Maybe I can make it a little bit far away. Lives in Anaconda, right into scene. Alright. Let me see the animation, guys, because I don't see it. And without seeing it, I cannot do it. Alright. Like in the solution, it says reverse scan for full or partial star matches, mark them. Work backward, greedily mark full or partial star. I guess we have our animation, guys. Let's look at it. Stabbing to sequence. Read it backwards. Unstep matched windows until all becomes question mark. I think. So we have a matching case ABC. Yeah. Blanket to So now match 0 to 2. Question mark is a wildcard for C. Unstop order. Well, what does this mean? Unstop order. Why can't I remove this? Let's make it bigger. Unstamp order. What does it mean by unstamp order? So, first of all, hmm, can you copy the animation into my clipboard? I am gonna paste it somewhere. Like, why are we doing this masking? Why are we going backward? What is the gradient? I joined the room. Let's see, let's see. Trust. All right. You can now send us images. Oh, wow. Let's see. Target AB, AB, ABC. Stamp ABC. All right. Start from index 0. Um, stamp index 0. Target. We inserted ABC. All right. And A does not match. Here. C and A? But why do we care about C? I mean, why not B? Let me read. Let me read. Stamp index 1. Target become like if we stamp here AB, yeah. You use some X's. Stamp index 2. Target now. So now target is this. Let's start at index 0. We restart. Target is this. Wallet. Wallet this, wallet this, wallet this. Oh my gosh. Thank you, Imanot. Like, you are doing great. Um, I have tons of questions. Um, let's see, First of all, let me paste your solution. Nice solution here. And also, um, um, so now the thing I wonder is that, like, we use question marks for some reason. I don't know why. And like in the animation, like, can you please explain the process we do and the reason behind it? All right. So what is unstep order? So in another solution I have, like we have like a empty array and then 2 and then 2 comma 0. So my friend told me that he represented the solution, I think, like using valid. What is this valid thing? What does it represent? And you have some unstep order array. What does it mean? So when we find a matching case, we blank it to question mark. But what does it mean? And now we also change the unstep order to 2. So what is the meaning of the 2 inside this array? And then you create a match like starting from 0 to 2, and we have like a b question mark, and you are telling me that like question mark is a white card for C. So I guess after making like a letters, like after turning them into question marks, um, they become a wild card basically. And then in the next iteration you make the first like a 2 characters in target equal to question mark again, and now the unstep order is 2, 0. And since all of them is now question mark, now we return success. You are telling me that reverse and answer 0, 2. What do they mean? The 2 is the index of which there was a valid stamp, a matching stamp. Matching. Target AB, ABC. We insert our stamp. So these are question marks, I think, I suppose, I don't know. Like our target is this one, we insert that stamp index 2. But what do we get? I mean, so now target is AB question mark question mark question mark. All right, we start at index 0. We start again. Add index 0 to list. This becomes valid 2. Valid 2 means 2 is index. When I stamp index 1, there were no matches. So we went to index 2. And index 2 matched all of them. Let's see. When I stamp index 1, when you stamp index 1, which is here, oh my god, all of them is different. When I stamp index 1, there were no matches. Yes, like literally there were no matches. So we went to index 2. There were no matches. All right, this means no match. So if we don't find any match, we continue. But what we do when we find a match in step index, we, oh my gosh, like we bull's eye, right? All of them match. Add index 2 to the list. So we add index into our list, representing that now at this index we can insert and we can find ABC, like we can generate what we want, I guess. So now so since we are able to all right, so these question marks, guys, I suppose it means that we can generate it whenever we want, I think. Order is not matter, right? um and question, yes, so I question marked all the matched ones, yes, all the matched ones. And the question mark, as the AI said, is a wildcard, so any letter can go under it. Yeah, all right. So C can match question mark, or Z can match question mark. So any letter. So 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 target was this, and we literally started from the index 0, stamp at index 0, and we have like we have like a match like AA, BB, and CC. C and A does not match. Yes. So what do we do? We we go. I mean, we try to insert stamp for another, but do we have to find matching case for all characters? But what if there is none? Then what are we gonna do? Oh, there there cannot. What is the constraint of target? I mean, can target be some ugly? Actually, yes, it can. And like, mm, all right, we are getting it. We are getting there. So, but the thing I wonder is, yes, we have to match for all the characters. But what if the target is let's say A B A B A B and A, not C, or let's say A B A C B, meaning that we don't have A B's consecutive A B C letters. What would then happen? I mean, what would then happen? For example, our target is A B A B A, and our stamp is A B C. Yes. How about that? I mean, is it guaranteed that in our target we're gonna have consecutive A B C's? I mean, is it guaranteed? Is it guaranteed? Then it is impossible. So you are telling us, Aymanat, that in our target we should have we should see consecutive A B C somewhere, right? Somewhere inside um, our target. I mean, we should have this. You are literally telling us this, right? We need to have these consecutive ABCs. But I thought, but I thought that is interesting. All right, let's read this a little bit. First, the forward story. What's stamping action? I know actually I don't see the reverse thing here. I mean, we just started from index 0. You start with a blank string of same length. Why we run it backwards? So why question mark comes back? Forward is painful. Later step overrides an error. So we start from and an earlier one. So you keep destroying your own work. Yes, like this was the pain. Yes, your pain point two. Yes, this was the pain. So we remove that pain. So we play the movie in reverse. Unstamp. To unstamp, we are not stamping in reverse order. We unstamp. To unstamp, to remove the last stamp someone placed. Oh, the meaning is this one. How do you support the last stamp? It's a window that currently echoes ABC exactly. This is why we are trying to find ABC exactly. It's a window that currently echoes ABC exactly. Yes, this is the logic. This is the logic I'm looking for. Because nothing was placed on top of it. Like, I'm gonna read your answer, but the question I have is that in the target, is it guaranteed to have to exist? I mean, like consecutive A, B, C. What happens in target? We have, let's say, A, B, A, B, A, B, all right, and our stamp is A, B, C. What would then happen? My friend says then it's gonna be impossible, but um, but for me, like I don't see why it may or may not be possible. Yeah, and also I like the idea of removing this pain by going backward, but backward does not mean going, I mean, stamping from left or stamping from right, but it means um, instead of stamping, we literally removing the stamp that earlier step done, right, has done. The question states that you must stamp in the window of the, you can't have AB, AB, AB because where will mm, it can go at the end. Like I can insert at the last index, I mean not last but before that, and C can be outside. What I mean is that let's say we have target AB, 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 right? We can insert ABC here, and then ABC here, and then ABC here, ABC here, ABC here. So when we look at, oh, then it becomes A. What about we go from right to left? Note that stamp must be fully contained in the boundaries of S in order to stamp. You cannot place stamp at index 3 of S. We cannot insert. All right. Yeah. I remember. Thank you, Ivanov. We cannot insert ABC here. Yes. In the beginning of the question, it is really stated there. We cannot insert ABC here, and also like the last space is here, and also even in this case, since we insert this, it will be A. No problem. Thank you. You can have any of the step outside here of the index of S. Yeah. Okay. All right. Like that constraint was important. Both of your points and your friend are exactly right. Let me show you why. Your second point first, you nailed it. Yes, backward is not stamped from right. So when you, Ayman told me that how about reverse order? Like I thought, like going left, going right. Which one? I mean, should I insert on target? Should I insert in a string, like a string array? I didn't understand anything. But the idea is not stamping basically. We don't stamp anywhere. Uh, either not neither in target nor the string, but instead we literally like a time reverse. I mean, we are going backward in time basically. Yes, backward is not stamped from right. It is reversing the operation itself. Instead of placing a stamp, you remove a stamp that was placed earlier. Oh my gosh. Direction along the string has nothing to do with it. We can scan left to right, either way. All right. The reversal is in time, yes. So place and unplace, not in space. That distinction is the whole trick. And you've got it. Not I got it. I may not got it. But I kinda get it now. Like kinda get it. Not fully. But now what will revert, like what will going backward give us? I don't know. So the ABB question, your friend is right. Here's the proof. Key fact. Think about the way. Alright, we understand this. How the reverse algorithm detects this automatically. You don't need to special check. The unstep loop catches it for free. Scan every window for one that matches ABC with question mark as wildcard. Like I don't understand why. Hmm. So since we cannot go beyond, I mean, since the last position we can insert is uh, to index before, then it means there will be. I may not redeem drink water. Thank you. So uh, it is guaranteed that we're gonna have. Like I don't see it, guys. Like why we're gonna have ABC consecutive ABC, like, and why it is guaranteed. Yeah, yeah. So you don't need a special check. The unstep loops catches it for free. Scan every window. So meaning the window, star stamp window, stamp length for one that matches ABC. Like, oh my, like for me to understand this line, I should understand why it is guaranteed that we're gonna have ABC in our target. Let me ask it to AI. Thank you for your cooperation. Now create a new entry, all right, and then explain to us that why it is guaranteed that we're gonna have ABC in our target. Because maybe we don't have it. I mean, maybe in our target it is AB, 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 right? Like I know that the last position we can insert is like a two steps before, but maybe we can insert there and we cannot insert. So so in the last two position in our target, they cannot be changed by anything, right? So that the target should have some certain type basically. Yes, oh my gosh. Target should have, you know, must have the last part of our stamp. But what is the length of it? Maybe one character or two character or the half of the length of stamp. I mean, like target should have like in every possible target they share a pattern. They share a pattern. Um, at least the last character should be same as the stamp last character, right? Because if it is not, then we cannot get it, right? But I guess it is not that important in this question. I don't know. If there is no stamp substring in the target, then there is no valid solution. If there is no stamp substring in the target. Yeah, yeah. Let me take a screenshot of it. Yeah, this sounds this sounds good, man. Where is our notes? I think. Oh my gosh, guys. Oh, here. Yeah. This seems good. Oh my gosh, guys. What is this? This is animation. Like even the understanding animation, even without from the animation, I don't get it because we literally start from like a reverse in time, basically, right? And we are looking for ABCs. Like you just dragged a real theorem and your at least the last character must match exactly the type bound. Let me say the entry. And also create another pain point where like we are looking for literally looking for ABC in the target. But I still don't understand why we should have ABC, consecutive ABC, given that our stamp is ABC. Maybe in target we don't have it. And I guess there is no target without ABC, right? But why? And explain and create an entry. Like I can understand like we are looking for ABC, like I can understand this part, alright? Like but I need reasoning for every of them. Like we start from index 0, but why? We said that we are going reverse in time, but here we just go from left to right, and we are looking for ABC. Actually, we are going from left to right, and again we repeat that process. Um, so, and we are looking for ABC. Why? And when we until we find ABC, we go and we find it, we mark and we make it wildcard. All right, and then we start again. I think. When we find it, we I guess store the index because we stamp there. Like I thought that like we all, of course, we are using stamps. We are stamping, right? But it doesn't have to mean that we should look for ABC in our target. Yeah. Anyway, we are gonna figure it out. So after finding these two, now we have like AB, and now add index 0 to the list. So since it is wildcard, we can insert ABC, and the insert index is 0. So 2 and 0, and we reverse it. When we talk about reverse, it's because the question says to stamp the question marks. But instead of stamping the question marks, we are unstamping the target to reveal the question marks. Yeah, so this is the thing I need to understand literally. Yeah, exactly. Um, Let me assign a color. When we talk about reverse, it's because the question says to stamp the question marks. But instead of stamping the question marks, we are unstamping the target to reveal the question mark. Oh my gosh. So we are working in reverse. Yeah, like I Like I kind of get it, but not fully, but kind of. So now I need you to create another animation for us, but in this animation I need to see the reverse logic. All right, I want to see the reverse logic, how it helps us. Suggest me some visualization ideas. Question says stamp stamp question mark to reveal ABC, but we unstamp ABC to reveal. Question says question does not tell us insert ABC to the question marks. Oh, actually we have these question marks, right? Yeah, we have it. I thought we came up with the idea of question marks, but in the string, in the string array, we literally have question marks there. The question says stamp question marks to reveal ABC. Yes, we unstamp ABC to reveal. So we are unstamping from target. So instead of all right. So instead of like going from string to target, we basically go from target to string, right? I guess. Yeah. All right. So let me exactly. All right. Now, like you've been telling me this, you've been telling me the very same thing for a long time, but that's what the question says. We initially start with the question mark, but we go against the question and we start with target. All right. That is what it means when it says we work in reverse. All right. That's what it means when it says we work in reverse. Exactly. Yeah. All right. Now we get it. Now we don't need that. So thank you. Now we need to wrap up because I want to advance to the next graded problem. And now the important part in this question was understanding the reverse, because my friend Aymanot told us about mentioned about the reverse order, but I couldn't manage to understand. I could insert stamp in string array S, right? Or I could insert stamp into target, right? I could do that. I could what I want, whatever I want. But the thing is, by reverse, it means he meant that like a working reverse in time, basically, right? Because the question wants us to build um, like a build from string, array of string, from array, from question marks, we stamp, and then we generate the target. But instead of doing that, why? Because we are genius, basically, right? Instead of doing that, we unstamp from the target because we know what we need. What we need is literally there, right? And we unstamp. But of course, I understand the logic now. But another important thing, except that, is uh, apart from that, is we are looking for ABCs, and when we find it, we put question marks there. And I need to capture the idea of why we are looking for ABCs, and I understand those parts. We are looking for ABCs, and I kind of get the question parts. Mm, since it is the last step we do, all right, we can see, we literally say that in the previous calls, it is doable. All right, I can, you built your logic, and I can stamp there, so don't worry about it. Like the question marks, or making, using question marks as wildcard literally means that. All right, do your job, leave the rest for me, all right? Because I can, like, since I am later than you, all right, I can paste like a stamp and make what I want. But now maybe the remaining part is why we are looking for literally A, B, C, and why it is guaranteed that we're gonna have A, B, C in our target. Now my remaining questions are these. Thank you for your cooperation. Now wrap up at these, create a new entry, and we're gonna continue with the next question. Oh my gosh. Um, the implementation for this is really tricky. Oh my. Now there is also the implementation part. This was for understand the logic part. If there is no ABC in the original target, it makes it impossible to stamp. But why? It does mean there is no order. I see, I see. I see, I mean, I kind of see, but why? Why it becomes impossible? And you are saying, you are telling me that the implementation is kind of tricky too. Like, like, it can't be, man. Come on. I mean, it would be great if the implementation of this is easy because we've spent good amount of time understanding this um, question. Uh, like I mean, what would we do to? I mean, actually, implementation is literally here. I mean, um, like string is mutable, and we have a for loop, and we have a window, right? And if they are not matched, we increase our index by one, and again check if they are matched. Um, we save the index, all right. uh, and then we can literally update the array, these indices, and make them question mark. uh, no, actually it is target, so maybe we can generate a not string but um, array of string, array of character maybe, right? So that we can update. And when we say, I mean, when the first character is, well, first character either match or question mark. But question, yeah, yeah, so this is target. So if the compare, like if the characters that we are comparing are match or um, it is question mark in target, we we can continue processing the next character. And if it is same again, we continue the next one. And since it is like I don't see any untrivial thing about it, I suppose. um it So imagine we are stamping and we do one last stamp. Yes, yes, one last stamp, and that means we are literally stamping a. Oh, yeah, 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 yeah. Oof. Yes, yes, yes. Exact, 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 exact. Yes, yes. This is, yes, yes. Like now you put the idea into words. Exactly, exactly. Like at the end, all right. At the end, we're gonna do this stamp somewhere or sometime, all right. But it is guaranteed that we're gonna, like, there will be a last step, all right. Like actually in the last DP problem, we've done this, guys. We've done this. I mean, thinking about the last movement. Oh my gosh, I didn't think. But this the question seemed so hard that I even like felt encouraged. Like my courage disappeared. All right. So the last step is like a stamping, right? So we literally we have to, like in the target. Oh my gosh. Yes, yes, yes. Say thank you, Ayman. Like literally stamping ABC into. Oh my gosh. Like it is. I get it. I get it. So if there is no ABC, like then we cannot. How our last step gonna? Yes, yes, yes. No matter where I stamp. Oh my gosh. Oh my gosh. Thank you, Aymana. Like, this is the proof I needed. This is the proof I needed. Yes, yes, yes. Like, again, in the greedy problems and DP problems, like we should focus on like a last step we are literally making. All right. Um, like the last step we are taking here is literally stamping, and in the previous DP problem, uh, the last thing we do, I mean, we create is the last subarray. Last subarray. Like there are some others, like there can be none, or there can be multiple subarrays, but the last thing we generate is the last subarray, and we focus on that part. Yeah, yeah, yeah. Like defining the question is hard. I mean, using atmos m and then the index. So I'm not talking about that part, but at least I should be able to understand the focusing on the last function, last process we do. All right, last action we take. Last action we take is generating a subarray, and here the last action we take is literally stamping, and that's why this is guaranteed to be an ABC. Oh my gosh, we are focusing on the last ABC that is guaranteed to be there. We search it, we extract it, then in the next, I mean, extracted version, then we're gonna see another ABC because guess what? We stamped that too. Oh my gosh, now I get it, guys. Now I get it. Now I get it. All right, all right. Thank you, Ayman. It was now at least at the end, at last, um, I enjoyed. I mean, after studying this question for a long time, now I see. Now I see. Oh my god, this is good. This is good. This is good. It was good, guys. Now I feel a little bit better about myself. Now I feel a little bit good about myself. Oh my gosh, what a question, man. All right, all right. Wonderful. And also, the target has to end with the stamp as well. Of course, oh, oh my gosh. I don't understand that part, but I literally got the idea of why we think reverse, because it is guaranteed to be like an ABC there, like for ABC to, I mean, the stamp to exist there. Like I literally visualize, and I could see it, but I don't see why target has to end with the stamp, because mm, like because let's say our stamp is ABC, I mean, it should end with the last character of our stamp, right? This about time. All right, all right, all right. The last character, the last character, because yeah, yeah, yeah. All right, all right. It need to end with the last character. Exactly, exactly, exactly. We cannot change it. Yes, yes, yes. In the definition of question we have this. Oh my gosh, what a journey, man. What a journey. Oh my gosh. All right, guys. All right. So, all right. Let's update the topic and take a quick break. I'm gonna have my lunch at 4 p.m. Today is gonna, like, we have still 12 hours left. Broken. Um, let's update the topic, guys. Like this. Mm, all right. So let's. We have the name. All right. We can add this to, not solved, but let's so actually implementation is not hard, right? I'm not. It can't be. Broken calculator open. Um. All right. Let me zoom out a little bit. Try it. Oh my god. Like after solving this, I will try it. I don't see any place where it can be hard, because string array is mutable. We can literally, like, we can create a sub loop, all right, and there we can literally check the characters. We can make the oh my gosh, like, Aymana, you are pushing me, man. You are pushing me. Let me, let me write it down. Let me write it down. Like, it can't be hard. It is impossible. It is impossible.
Magic was in your hands the whole time. Now cast it.
All right, now let me cast the magic. All right, now the magic. The magic part is actually was about the understanding reverse order. Oh my gosh. Let's start. Let's start. So we are checking. Like, we can have a method, like a sub, like a helper method, all right, that will return boolean, right, and let's call it helper. All right, it's gonna tell us if the all characters are matched with the given window. By window we mean, let's make it start 0, I smaller than not the length of target, but the minus length of the temp plus 1, the maybe plus 1, I don't know. Let's add plus 1 for now. Since they are not array, we need these parentheses, all right, and then I plus plus. So if so, we are looking for matched like ABC, all right, we are looking for ABC. We start from, and that loop should start again. Oh, then it means we cannot use a for loop, right? We need to use a while loop, that it's gonna start over and over again until maybe we can make use of an index, right, and while index is not equal to target dot length minus 1, right, no minus stamp length, right, all right, we should check if helper function, if it is true, we do. If it is not true, we move. This means that we find ABC. We find ABC. If we find ABC, now make it so we need another array. Where is our string? I mean, string array. I think we're gonna create it, right? No, where is it? I mean, we need to create a string append, because we need a mutable thing, right? String length of with the length of target. Back in time. New string with the target length. All right. So we should initialize it with question marks. Anyway, make it question mark, question mark, question mark. So it means that we have found ABC, right? We need to find those indices, which is index plus 1, index plus 2, right? Actually, if we pass the index, it will be index, and maybe the length of our stamp. Yeah, maybe int length of stamp, right? And we're gonna have some sort of for loop, and it's gonna, we also need, we have found ABC, and we're gonna make this back in time question mark. So we need this array, I think. Back time. We have found ABC. Now we're gonna make question mark, question mark, question mark. From starting from where to where? Starting from index with the length of so we can use a for loop too. 3 times basically, right? Integer I start from 0 3 times, meaning smaller than 0, smaller than length. All right, I plus, and we need to assign I to question mark, not like this one, of course. Make, so starting from index, we made like a question mark, question mark, question mark. When we find, but the time, like we don't worry about time complexity yet, right? So we have a while loop, and for each time we are checking if they are, you know, same. I mean, not same, ABC, ABC, yes, same, ABC, ABC. If we find it, we let's share the index and then length of the stamp, which is stamp dot length, and then reference of this one. All right. Yeah. So we find ABC. If we don't find ABC, we just for advance. All right. We start from in the, like I'm literally copying what you have just said. All right. Start from index 0. Check if they are matched. If they are matched, ABC. If not, we move forward. If index until where target length minus like a maybe 6, maybe not length 5. I mean, it should be let's say we have A B C D as target and ABC, like this is the last index we can paste. I mean 0 1 2 3 length, actually 4 minus 3 basically, length of target minus length of stamp, length of target minus stamp of length of stamp. If we find ABC, now we literally make them equal to question mark, and also we have AB here. Where does so we literally need to create this back in time as like maybe another for loop, all right, because we need to populate it. Integer I, integer smaller than like a target length, all right, and we should back in time, right, I, and we should set the value for it same as character at I. So now we populated our baking time. We should call it another thing, but for the sake of time, uh, all right. So we have the reference of it, and why this is this cannot make static reference. All right, since it is static, why it is static? Don't make it static. Um, if so now we should make it. Actually, this one is literally making. So we should call this method inside here. So we need another helper method to see if they are matched. We literally need to call this function over here. Now we need another helper function for seeing match. Is match. Boolean is match. Match. So we need another for loop again, right? And we need to we literally need to check each character, and if any of them is not matched, we return false. If we don't return false, we return true. uh, so let me look at one thing. All right, so we need to check each character. We need, I guess, targets, right? And then baking time and baking time and actually actually if it is not either, uh, if it is not target character at, if it is not, I mean, if it is, then we don't worry about if they are equal to, I mean, no, if the if the in the baking time. All right, so we can continue basically, right? If in the baking time, if it is equal to question mark, then it means that we can continue. Yes, we can continue, or but it can be the last character. So return statement is outside the for loop. All right, so we can continue. If the so it is matched basically, it counts as match, but if they are not matched, I mean, meaning that like character at I is not matched with baking time, then we return false. So we call this is match method here with the target and baking time. Target and baking time. Where is baking time? Baking time is here. Baking time. Where are we? Baking time. So we check, like, this is costly, but I mean, this is the first thing I could come up with. Maybe there can be other ways of doing that, maybe counting not frequencies, but we literally maybe using sliding window or something. Would it help in terms of time complexity? I don't know, but we literally need to check each character, but starting from where? We need start and end index, or at least start. uh, I mean, we should give it is index. This is from starting from there, like index. All right, all right. Yeah, yeah. So integer start. We need to we need to start from there to compare if they are equal, not from starting from zero, but instead like a not zero but start, and plus start. How about that? Length, like a, for the length. I mean, for 3 times basically. If the length is 3, for 3 times, starting from start index. All right. We compare. If it is equal to question mark, then we continue. All right. If they are not equal, then it means we need to go one forward in index. So if they are not matched, we go one forward, one step forward. If they are matched, then we make our back in time starting from index. We make it so. And so what does our method is what does our method what is our method gonna return? It's gonna return the indexes that we have find is matched. So basically we need another, like a answer or something, right? String answer, new string. The length is, I don't know the length. Let's use it. Let's use string builder. I don't know the length. String builders sp equal to new string builder, and when they are matched, let's add or append the index, and we return this dot reverse dot to string, and we return that. Is it does it look good? I'm not. But what do you say? What do you say? I mean, I didn't think of um any better like a solution. I mean, we are literally doing what you have done here. Like, we are literally starting from index 0, comparing every character. If they are same, we mark them. My bad, I was trying to do. Oh, my bad, I was trying to do. So no, it's like it like let me copy the code and paste it and see what we get. And the name of the question was stamp the sequence. Stamp the sequence. Let's see. Like, I literally done what you have done without any without thinking. Like, I don't think about sliding window, 2 pointers, binary search. But let's see. Our method is this: return. All right, we can make it public. I have partially working one, but very inefficient, yes. So it fails time limit after 35. Oh my gosh, guys. Like understanding the logic part is one layer. Coming up with the solution another, and coming up with a like a time efficient solution is another layer. Come on, man. But we're gonna get there eventually. So the function is taking these arguments. Let's try, guys. I don't know. So incompatible types. So we are trying to store. I think your one is good. My one was n to power 2 times m n squared times m. Like mine isn't like doesn't look good, but I don't know if it is better than yours or not. Like for each index, I didn't think about the time complexity. Like we are looking again. How many times? How many times? For the length of uh, but multiple times. I don't know. No, your one looks. That's interesting. That's interesting. I really wonder your approach too. You can add your solution in the live code as well, and you can check. Let's see. But how do I store? Mm, how about I? How about I do this? Let's see. We are still getting it. Cannot be differentiated because it is character. Maybe we can store not string but character array. How about that? Like I literally need to study this conversion. How about that? We store characters, right? These are characters, yes. And in our string builder, add we add the indexes. Yes, yes. All right. Let's see. Is match target. We have found a character cannot be converted to back in time. So we need to change this one too. Character and here. Yes, I send it, but my code looks very messy. Let's see. So oh no, like in the live code, uh, in not in the live chat, we have a live code tab in the in the main section. You can paste there, and it has Monaco editor there. The code should be good there. Oh, we should return. Yeah. I put in like how do we? I'm gonna look at it. How do we string? How do we convert string builder? It's in Python. Let's see. This looks good. I mean, I don't know, but I don't know about the time complexity. But while like, let me take the screenshot and first complete my solution, and then let me read it. Stamp the seconds. All right, this is your solution. Almanacs. The thing is, how do we convert? Like we have string builder, we add indexes. Now I need to, get them in reverse order. String cannot be converted to integer array. It is integer. I don't know. Cannot find symbol length stamp. I guess the conversion is. Let's see. Let's see a Java example. How do you convert? Like I need to study this. Mm. Integer parse int. How about that? But here resulted in is integer. Integer. We should return integer array, right? Yes, we should return integer array. All right. We have string basically. How do we convert these guys? We should reverse. Now we should turn this into integer array. So maybe using another for loop. How do we convert string to integer array? Depends on what your string actually contains. My string is real string. We need a for loop basically. Without a for loop, we need a for loop. S nokta cars. What is S? It is string. How about we do something like this one? Would it work? Can I call this? Let's see. Or otherwise, I'm gonna use a for loop. Cannot find symbol. Which symbol are you talking? Length of stamp. Yeah, we don't have it. So maybe I should length stamp here is matched and length. What is length? Stamp dot length. Let's see. Missing return statement. Which return for boolean hyperfunction? Actually, it is no. It doesn't need to return anything. It is void. It should update. Change in place. Update in place, basically. Memory limit exceeded. Now I'm gonna take 5 minutes break and then So even this stamp and target memory limit exceeded, guys. So we literally, this is not good. I'll be back in 5 minutes. All right, break 5. We are back, guys. Now we hit the memory limit we hit the memory limit basically, and even with this one, so I don't imagine how bad our code functions. Where can we improve it? So we have a character array, we have a string builder here. I mean, this shouldn't be that hard. We have this magical thing. So I don't know, like I can focus on improving this. Now, like we're gonna take 1 hour break, right? It's been almost 4 hours that we've been working, and when we back, we're gonna continue with this broken calculator problem, and yeah. So let's read this. Ready for the next critical problem. Alright, I did it. I just added a visited array. Visited array. Instead of checking, so after wonderful, good idea, after like we set question mark, and then we don't need to look those positions again. Actually, I continue here. So maybe in your solution adding visited array solves, but I already like skipping those parts. Memory limit exceeded. Open the case. I mean, like instead of using a visit array, I literally continue. You need to skip the index that you just stamped. Not all the. You need to skip the index that you stamped. Let me take a screenshot of that part because this was important too. Instead of skipping the question mark, but how we hold these indices here, right? And we start from, actually we don't set the index again. I mean, yeah, like I don't have that logic. I mean, it goes from left to right, and then when it reaches the end, it should start again, right? Or I mean, in the solution we are doing that. Where is it? Let's start at index 0. I don't do that. After finding, we should start. Is your code also comparing ABC to, because that is also valid. It is comparing, yes. It is comparing, and it is comparing, and if it is question mark, it is valid. My problem here is that I don't reset index, so that's why. I mean, maybe after fixing it, we could get some result. Is matched. Maybe after that part we should set in, where do we set index 0 again? Each time we set question mark, question mark, question mark. Let's see. The memory limit is exceeded, so it doesn't even give us a result. Even with this target, how come? Maybe instead of character, how about this one, right? Maybe it is because this. Forget about wrapper class. You set index 0 after you have gone through the whole target. I mean, yeah, I mean, but all right, to the end. I mean, after you reach end, not after you set, stamp, not after you stamp, basically, or unstamp. All right, not after. Yeah, after you reach the end. After we reach end, I don't do anything basically. If we reach end, if index is equal to target length, then set it to 0. How about that? My while loop restarts the for loop. I'm gonna check it now. Oh my god. So while loop, and if it is not equal to question mark, I'm surprised my solution beats 83 of people. 83% of people. So nice. Like my solution stacks memory. Where do you restart your while loop? Actually, you don't restart. You basically wait until all of them becomes question mark. All right, maybe I should use that one too. But how about index? How do you, which index value you are using? I mean, in while loop we have, and for loop, when for loop finishes, it runs again. Like, we have character array with the target length, yeah, and I'm making, maybe instead of creating this character array, but I should be able to manipulate the target. How do you write, how do you manipulate the how do you manipulate not solution, I think. How do you manipulate what? How do you manipulate? Like, since we have string, we should turn it into some sort of, we have target, and you created a target list. Yes. All right. You created that list. So I also create that target list. Yes, like a character array. Yes. And also I create a string builder to for what? Why did I create a string builder? To store the result basically. Maybe I can use an array for that. And maybe, but I don't know the size. I don't know the size of that output. So how do you handle something that you don't know the size? You just create empty array. But in Java, I cannot do that. I need to tell the size of the array before initializing. Instead, I use string builder, but maybe this is why memory limit exceeded. And other than that, I don't create. Yeah, so most probably it is because string builder.